Again. Is it diameter by pi divided by 2?
Good afternoon, everybody. Can you hear me? Can you all see the screen?
Yes, sir.
Yes, sir.
All right. I must apologize for being late, but some equipment that I need for the class, I scheduled to pick up to get the equipment and it came late. All right. So apologies for starting it. What that means that we would normally start at 5. So basically starting about an hour earlier today. So basically halfway between we will normally start. Right? So we're still gonna get the work done. That's the bottom line. Right? So I'm gonna do this session, and it will be good if we can finish off basically all the topics that we're revising today. If not, then we can do another session tomorrow to finish them off. In terms of what we have done so far, we have covered all the questions in number 10, which is the vectors and the matrices and the transformation. We have covered the number 9, which is, well, not all of number 9. We have covered the sine rule, cosine rule questions, right? Which is bearings and triangles that are not right angled. We have not yet done circle theory, so we can maybe decide to do circle theory now in number 10. All right. We did part of number 8, which is functions and quadratics. We did that as well. So we covered number 8. We have not yet done this topic, which is basically the pattern question. All right, so we have that to do as well. And we have not done any question on number 6, which is some measurements. A question on measurements. All right, area, volume, and all these things, right? Measurement question, number 6. And we have also not done number 5, which is statistics. We have also not done number 5. So between today and tomorrow, we should be able to cover all of those. And with sufficient time, we can jump down to number 2. Well, number 1 actually. Number 1 and number 2. Number 2 is your factorization and your algebra, so on. And number 1, which is your consumer arithmetic, your fractions, and the number theory. Number 1. All right. So I'm suggesting that we start with circle theory today. Okay?
Yes, sir.
So, good. So we're gonna do all the questions on these 5 papers on circle theory. All right. All right. So let's go. So to do the circle theory, remember this is a revision class, so we're not really teaching the thing from scratch. So to do the circle theory, there are about 7 rules that you must know. All right. There are about 7 rules that you must know. And I can do a quick recap of them. Right? If I have that diagram. Let me see if I have that diagram that we can use. There's a diagram that we use in the class. It covers those 7 rules. Let's see if I can find it here. It's supposed to be in the down rows. You want something urgent, you usually have a problem finding it. Not that. Remember that image, that diagram I gave you guys? Talk about the circle theory. Summarize. Let me see if I have it here. Let me just see if I have it here. It's a nice way to summarize the rules. If you want something, you can never find it. All right, I'm not seeing it here now. Huh? Yeah, that picture. Yeah, that one. What's that? Yeah, but I'm not going to get it on this. I don't remember where in the document, where in this thing it is. I don't remember, so I'm not seeing it here. All right, so we just have to proceed without it. I'm not seeing it. I'm not seeing it. I don't know where it is. All right, but we can still on if it's inside here. Let's see if it is inside here. In the file for the top. So let's see if it is inside here. Ah, here it is. It's inside here. So basically, the process online can maybe screenshot this thing. This basically summarizes several rules that you need to know. All right. So the first one is what we call the center rule. Angle the center is twice angle the circumference right here. When both angles are subtended by the same chord or by the same arc, right here. Center rule. Both angles subtended by the same arc or the same chord. How do I undo this thing now? What do I undo? I don't want to use this undo. Right? Or it could be a chord subtending both angles. That's the first rule. I call it the center rule. Angle at the center is twice angle at the circumference. Then we have this one that we call the diameter rule. Angle subtended by a diameter at the circumference will always be 90 degrees. We call it the diameter rule. Sometimes they say the angle in a semicircle is 90 degrees. Then we have what we call the tangent and radius rule right here. The angle between a tangent and a radius is always 90 degrees at the point of tangents. Angle between a tangent and a radius is 90 degrees. Then we have what I call the two tangents rule. Two tangents from a single external point. Those two tangents are equal in length. You can see them here. They are equal in length. That's one. And the two tangents, let me use a different color. The two tangents together with the two radii, they form a cyclic quadrilateral. Those two tangents and those two radii form a cyclic quadrilateral such that the opposite angles, see, the x plus y equals 90. So the angle between the two tangents and at the center there between the two radii will always add up to 180 degrees. Why is that? Because the angle here is 90 and the angle here is 90. So those two angles add up to 180 degrees. So that's a cyclic quadrilateral because the opposite angles add up to 180 degrees. And they can ask you that in an exam. Why is that quadrilateral? All right, guys, seems like the signal just dropped a bit a while ago. We'll come back to this. All right. Then the next rule is what we call the same segment rule. Over here, angles in the same segment of a circle, subtended by the same arc or subtended by the same chord, those angles are equal. Right here, they are subtended by the same chord. Oh, this thing moved. Subtended by the same chord. Those angles are equal. Angles in the same segment of a circle are equal. Then we have what we call a cyclic quadrilateral rule. A cyclic quadrilateral is formed when there is a quadrilateral in the circle such that the four vertices are on the circumference. If the four vertices are on the circumference of the circle, then that quadrilateral is cyclic. And the opposite angles are supplementary. the opposite angles add up to 180 degrees. So these two add up to 180 and these two add up to 180. All right, and we can see that down here. We can see it down here and there. All right, that's number 6. Then now we come to what I call tangent and chord rule. They call it the alternate segment theory or the alternate segment rule. I call it the tangent and chord rule. How it works is that the angle between a tangent and a chord, that's a tangent and a chord, and this is the angle between them. It is equal to the angle subtended by the chord over there in the alternate segment of a circle. So this angle is x as that one is. All right, and if we look at the other side, the angle between this tangent and this chord is this angle y right here. It means that this chord is going to subtend that same angle at the circumference over there. Y. The angle between a tangent and a chord is equal to the angle subtended by the chord. So with those rules, and then your other rules, your other measurement trigonometry rules, like for example, Z angles are equal. Co-interior angles, like the angles in a U add up to 180 degrees. Angles that are vertically opposite are equal. Those rules also apply. Like for example, again, the isosceles triangle, right? We know that a sector triangle is an isosceles triangle. So if I were to draw one right here, I have a line from the radius out here and out here, and you complete the triangle. That's called a sector triangle. It's a triangle in a sector. It is isosceles because this radius and this radius is the same. And so these two angles are equal. So these are some of the basic things that we apply. So these 7 rules, along with our normal trigonometry rules, apply. All right, our normal measurement rules apply in this question. All right, so it's just a quick revision on that. But these are the rules you need to know. So if you don't have it, you can just screenshot it. It's just a summary of them. You can screenshot it. This is it. Clear everything. All right, and that is it. It's small. So you can screenshot it as a good way to, remember the rules. Just screenshot it. All right, that's it. So let's get to the questions now. So we're going to start with this one, which is the January 2023 this year, right? And sometimes CSEC make questions with the angles on these. It happens from time to time where they make mistakes with the angles that they give. The angles that they present to you are inconsistent sometimes. All right, let's see what this one says. It says the diagram below shows a circle with a diameter KF. So this diameter, this is a diameter. So once I see that's a diameter, I'm thinking about the diameter rule. Angle subtended by a diameter is 90 degrees. So I know that this angle up here right now is 90 degrees before I even start. All right? What else did they say? They said line EFG is a tangent. This is a tangent. So once you have a tangent, you're thinking of tangent and radius rule, tangent and chord rule. So this will be a tangent. This will be a radius, sorry. So the angle here is 90 degrees. Angle on this side also is 90 degrees, tangent and radius. Also, you will have tangent and chord. So for example, this is a tangent, that is a chord. So right away, this angle between the tangent and the chord will be equal to the angle subtended by the chord up here. This angle. See, that angle up there. Those angles are equal. Angle between tangent and chord. If you use the other side, tangent on this side, and the chord right here, and this is the angle between that tangent and that chord, then the chord subtends the same angle up here. So right away, I know that since this is 56, this is 56. Because the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment. All right? All right. Then we have two same segment rule. These two angles are equal because they are both subtended by this chord. Or I can know, I can trace back to see the chord is subtending. That red chord is subtending this angle. Same chord is subtending this angle. So it means x equals 56. X equals 56. All right, so those are some of the things we can identify before we even start solving the question. All right, let's answer the question. Let's continue and answer the question. It also says that that's a tangent at F. That's what we reach. And it says point F, H, K, J, they all lie on the circumference. So basically, everything that is set up here is represented on the diagram. And normally what you do, you read the information up here, and if there's anything that is said that is not on the diagram, you write it, you put it on the diagram. But you're not gonna go and read this again while you answer the question. You're not gonna go and read that again. All right? So let's see. So I identified a couple things. Let's see what they want us to do. It says, by showing each step in your work where appropriate, find the value of each of the following angles. I want angle X. So this is angle X right here. Now let's say look at it, and we identify that it is same segment to that one, so it's 56. But let's say I didn't know. What I usually tell the students to do is find the chord or find the arc at the subtended angle. So you would track back like this, to find the arc or the chord that is subtending the angle. And it is this chord that is subtending that angle. And you say, what else is the chord doing? That same chord is subtending this angle up here. And that is why they are equal, because angles subtended by the same chord in the same segment are equal. All right? So that is it. It equals 56. So the x equals, angle x equals 56 degrees. I don't like to put on the degree because the question said x degrees, right? So the x is just 56. So the angle is 56 degrees, right? But the x is just 56, but the degree already is on the x. Everybody go to that one, and we have to write the reason, right? Angles in the same segment. Angles in the same segment are equal. And usually that's not the full story, but it's supposed to be angles in the same segment subtended by the same chord or subtended by the same arc are equal. But if you write this, CSEC will give you a marks. But if you have time, you can write out the full thing, right? The angles must be subtended by the same chord or subtended by the same arc. All right, that's the first one. Any questions on that? Very good? Online?
Yes, sir.
All right. Next one. They want us to tell them angle Y. Let's look at the diagram. Angle Y. So we know that this is 56. And usually, once you find the angle, put it on the diagram because it might help you to find other angles. Right? So we tend to put it on the diagram. So this angle right here is 56. Put on the diagram. The next angle I want is this angle Y right here. All right. So that angle is not at the center. All right. That angle is not at the center. All right. So what happens? We can look at this triangle now. This, see this angle? It is an exterior angle to this triangle. So you see, it's not the circle rules apply in these questions. Other rules apply in these questions. So that angle Y, if we take this side on the triangle and extend it out this way, and then complete the angle between the extension and the adjacent side, that's called an exterior angle to this triangle. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. So this angle Y is equal to the sum of this one and that one. So the Y is equal to 56 plus 19. I'm leaving off the degree because the question said Y degrees. So Y degrees is equal to 56 degrees plus 19 degrees. We can leave off the degrees because we're just trying to find the value of Y. The rule is that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. But I go to that one. But okay with that one?
Yes, sir. Yes, sir.
So let me demonstrate it up here again, right? With a simple triangle. So let's say I have a triangle like this. And I form an exterior angle by extending this side and form the angle between the extension and the adjacent side to it. This angle X, these are the two opposite interior angles over here. Let's call them A and B. It means that the X is going to be equal to A plus B. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. All right, and that's what we're going to apply for this one right here. That's what we're going to apply to find that. All right, so basically it is equal to this 56 plus 90. So 56 plus 20 would be 76. So this is 75, right? So this is 75 degrees. So this is equal to 75. That's 75. So the angle inside here says 75. So let's write it. So angle Y is equal to 56 plus 19. And that's a degrees. That's an angle Y. So we're going to write degrees on it, which is 75 degrees. And the reason is that the external or exterior, the exterior or external angle of a triangle is equal to the sum of the two opposite interior angles. Right? So right here, Y is the exterior angle of that red triangle that I drew. So it's equal to the sum of the opposite two interior angles. All right? Want to go to that?
Yes, sir.
Yes, sir.
All right. So let's put it in. I always put in the angles as you find them because they will help you to find other angles. So this angle right here, so now is 75 degrees. 75 degrees. All right, 75. All right, let's see what else they want us to find. The next angle they want us to find, oh, them done. That's all. They don't want anything else. So the question easy. That finishes that question. Circle theory and this one is done. Okay? Done. So that's a little bit. I said I didn't ask any question about using the tangent. Notice? They didn't ask any question using the tangent. But that is it. All right, let's go to the number 2 paper. So we're only focusing on the circle theory questions now, right? Circle theory. Let's go to the number 2 paper, which is June 2022. The number 2 paper. Number 2 paper. This one. Now we're looking for the circle theory. Circle theory. This is circle theory right here. All right, so let's see this one. So this question says, H, J, K, L, and M are points on the circumference of a circle, and this is the center O. MK is a diameter, so this is a diameter, so I'm thinking about the diameter rule. Angle subtended by a diameter up here is 90 degrees. So I know that this is 90 degrees before I ever start. Angle subtended by a diameter is 90 degrees. It says, and MK is a diameter and it is parallel to HJ. And you could know that it is parallel, these two parallel. Oh, we know them parallel because I put these arrows on there. Arrows on lines mean that the lines are parallel. And then it says MJ equals JL. That's this one equals this one. And we know that them equal because they put these lines on there. So when I put these little marks on the lines, it means that those lines are equal in length. When I put arrows on lines, it means that the lines are parallel. All right? So since these two lines are equal, it means that this is an isosceles triangle, this. Don't it? That's all? So it means that the angle down here and the angle up here equal. That's all? Don't it?
Yes, sir.
Good. Because the angles that are opposite the sides will be equal. The angles that are opposite the sides of equal length will be equal angles. And then let's look at the parallel lines now. Let's see if we can deduce some stuff on the parallel lines. So these two lines are parallel. So this now will form a Z, don't it? On the parallel lines, don't it? By putting this transversal line, they form a Z. And so this angle and this angle are alternate angles, them equal, don't it?
Yes, sir.
That forms a Z. Good. That forms a Z. What else we can get? We can put this line down here. And so we get the U angle. So this angle here and all of this angle here, they are co-interior angles. They add up to 180 degrees. That's all? Add up to 180 degrees. So these are just some stuff we can identify before we start. These two also join the parallel line, these two. So it means that this angle, all of this angle, and this angle right here, those two also add up to 180 degrees. They are co-interior angles. All right? Is there any cyclic quadrilateral in this? Yes.
Yes, sir.
This is a cyclic quadrilateral right here. This one is cyclic because the 4 vertices are on the circumference. And so these two angles across there, they are supplementary. They add up to 180 degrees. Similarly, this angle and this angle across here, also those two are supplementary. So these are just some things that we identify before we start. There's another cyclic quadrilateral in there. This one is another cyclic quadrilateral. This one. It's actually a trapezium. Right? So it means that this angle and this angle equal because they are opposite each other. And this angle and this angle equal. They are opposite each other. So I'm just identifying some stuff just for the purpose of the revision, right? All right, let's see what they want us to find. So everything that they have set up here is represented on the diagram. So any information we want, we can go on the diagram. So the question says, explain given a reason why this angle is 38 degrees. Which angle is that? HJM. HJM. Give a reason why this angle equals 38. It is because it is alternate. This one, note it. Alternate angles are equal. That's all? That's the reason. Alternate angles are equal. I can say alternate Z angles are equal. That is why. These two angles are alternate angles. Angles in the Z, right? So we can say alternate, which are called Z angles, are equal. Remember, you can only have alternate Z angles when you have parallel lines. If you don't have a pair of parallel lines, you cannot be talking about Z angles. You cannot be talking about alternate angles. You cannot be talking about co-interior angles, or we call U angles. First thing you must have parallel lines in order for you to have those things. So the diagram, if thing looks like a Z, but the lines are not parallel, that forms a Z, then you don't have Z angles. You understand? You must have parallel lines. So if I have a line going like so, and a line going like so, and another one going like so, looks like a Z. But if this line and this line not parallel, so these are not alternate angles, because this line and this line not parallel. See that? You must have parallel lines in order for you to have Z angles. All right. So that is the reason for that one. Nobody good? But okay?
Yes, sir.
Yes, sir. Yes, sir.
Good. So let's put the 38 on the diagram right here. As you find the angle, you write it down. 38 degrees. Because the more you fill out the diagram, the more information you have to answer your questions. All right, what else do I want us to tell you? We must explain again why angle MJK is 90 degrees. MJK, let's look at which angle they're talking. MJK. That is because it is subtended by this diameter. MJK is the angle in the semicircle subtended by the diameter. So we're going to tell them that it is subtended by the diameter MK, right? So that is why. Simply that. It is subtended by the diameter. MK. That angle is subtended by a diameter MK. That is why it is 90, because angle subtended by a diameter is 90 degrees, right? Very good? All right, moving on. It says now, determine the value of each of the following angles. Show detailed working where appropriate. So I don't really ask you the reason, but you must always give reason still, if it requires reason, right? The one angle MJL. MJL. Let's look at the diagram. Angle MJL.
Yeah, MLJ.
All right, MLJ. Thank you very much. MLJ. 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 So the question is basically asking us about this angle. All right, we want that angle. All right, let's look at it. So you're trying to find this angle right here. All right, so we know that this angle is opposite to that. So we can find this one good. All right, any other thing? It is a part of this triangle, which is an isosceles triangle, don't it? So these two angles equal. All right, so we can find this one up here, we have that one. All right, so if we're going to find this one up here, we would need this small piece. I'm just trying to see, I'm not seeing it right out the bat. So I'm just trying to see if you can find this angle, will go, don't it? Up here, don't it?
Yes, sir.
No. But then that angle is equal to this one over here, don't it? Don't it? Because they are both subtended by this chord across here. So the question now is, can we find this angle right here? Can we find that angle?
Yeah.
All right. Huh?
Yes, sir. Yes, sir.
All right. So let's work it down. Let's work it down. Let's work it down. All right. So since this angle is 38, right? That angle is 38. This angle is 90. Let's go step by step. Let's fill out some of the angles. So this angle is 38. This angle right here is 90. We just did it a while ago. So it means that this angle and this angle complementary, right? That's all. Got
Yes,
it?
sir.
Good. So this angle down here is 90 minus 38. This one. What is that equal to? 90 degrees minus 38 degrees. Which is how much?
52 degrees, sir.
2. Good. 52 degrees. 52 degrees. And then these two angles equal now, don't it?
Sir.
Because they are both subtended by this arc. Or you can say they are both subtended by this chord. So these two angles equal. So this angle is 52 degrees. This one asks us for, right? 52 degrees, right? So sometimes you have to do a little bit of work first. That we're just get the angle straight, right? So it is equal to 52 degrees. So it's same segment here. So the first thing you have to tell them is that these two angles are complementary, because total angles in this right angle triangle, that's a right angle triangle. Total angle in there is 180 degrees. This part is already 90. That angle is already 90. So these two must add up to 180. You can actually show your work on the paper like this. To show your work on the paper like that, CSEC will give you a marks. So you have indicated where you get it by just doing this, right? And then we're going to say that this is 52 and this one is equal to that part of the same segment. So let's look at it this way. We're going to express it. And the thing about it, the diagram is not on the screen. That I don't like about doing this. Let me bring up, let me split the screen and bring it up again. Let me split the screen and open it up again. So the diagram remains on the screen. Where is it? I have to go back for the file. I have to go back for the file. Discard. I want to bring up the diagram on the screen so we can reference it in our explanation. So, all right. Just bear me a second, guys. All right. Now, so this is the same question. So what I'm going to do, I'm going to leave this diagram on the screen and write the answer on this one, and then we can copy it across. All right. So we're trying to find this angle, right? We work it out already, you know. That's the angle I want, right? MLJ. This angle right here. We say it is equal to 52. Same segment. So let's write it out now. Or present it in the exam. We're going to say this angle is equal to this angle of the name, this angle. That angle is MKJ. It is equal to angle MKJ, which is equal to 90 degrees minus 38 degrees, which is 52 degrees. So we're basically saying that angle is 52 degrees. Huh? This is MLJ. MLJ. Let me zoom it up. See, this is MLJ. But it is equal to MKJ. But they are subtended by the same chord. You see, MJ subtended both of them. See? That's why you have MJ, MJ. And the point in the middle is subtended by MJ. All right, that is it. So it's 52 degrees. But the question never really says X degrees, you know. It's a show working where necessary. So this is sufficient working. All right. But here now we can say same segment. Angles in the same segment are equal. Angles in the same segment are equal. And we did show on the diagram why this is 52. Because we did 90 minus 30, right? So that is 52. So let's put this 52 on the diagram in case we need it. Always fill out the diagram as you find out. So this is 52 degrees. 52 degrees. All right. The next question I want, next angle I want is angle LJK. Angle LJK. Where is that now? Angle LJK. LJK.
Excuse me, sir.
Yes.
So just to clarify, for MLG, you decided to say that this angle in the same segment when we're talking about MKG?
Yes, these two angles equal, these two. Because they are both subtended by this chord.
And we'll get the marks as long as they see the working as well, right?
Yeah, because the question, if you notice, you know, the question didn't ask you for a reasoning, right? It's a show working where appropriate. This one didn't ask for reasoning. And if you notice, when they want a reason, they tend to give you lines for you to write the reasons. You understand? They tend to give you lines to write the reasons. So this one really wanted the calculation, but I would still say this, just to make sure. And writing how your angle is found on the diagram is also sufficient to show where you get it as a part of your solution. By doing this, as a part of your solution. So you have indicated why this angle is 52. You did the 90 minus 38. If you want to write complementary angles down here and say it, then fine. Still sufficient. Once the answer is on the paper, they must give you your marks. You know? Once it is there on the paper, they must give you your marks. All right. So the angle that I want now is this one. This small angle right here. I marked it a different color. Trying to find this angle now. This angle. And we agree that that angle is equal to this angle over here. Because they are both subtended by this arc. Both that arc subtend those two angles. So those two angles equal, this one and this one. So basically then, if we same segment again, if we can find this angle, then we basically have this angle. All right? So the question is, can we find this angle here? We have not used a Z yet, you know. We don't use a Z yet. We have not used a Z as yet. You must use it at some point. We have also not used this isosceles triangle as yet. Right. So what happens now is that, as we said, because this is an isosceles triangle, guys, and this 52 degrees is equal to 52 degrees here. So this angle, this whole angle here is 52 degrees. All of this is 52 degrees because of the isosceles triangle. And so this small piece, this small angle right here now, this small angle right here becomes 52 degrees minus 38 degrees. Because the whole thing is 52 because of the isosceles triangle. And then now this angle over here is equal to this, whatever this is. So 52 minus 38 is how much? 14 degrees. So this angle therefore is also 14 degrees. So it's just a matter of how you present it in this small space, right? That's all it is. So I'm going to tell the examiner that this angle over here is 14 degrees first. So watch me now. I'm going to say this angle is equal to this angle. I'm going to name it as being equal to this angle first for same segment, which is equal to L is equal to angle LMK. This angle is equal to angle LMK, and this angle LMK is equal to 52 degrees minus 38 degrees, right? Which is the 14 degrees. And I'm going to state the two things that happen. I'm going to say that this is an isosceles triangle. That's why the 52 is there. All right? So I'm going to say that MJL is isosceles. And then we're going to say same segment. These two angles are in the same segment. I can just write it right here. Same segment. Same segment. So basically using the same segment rule. Angles in the same segment. They do that, they'll give you a mark. This question really only wanted to calculate this one. Alright? That is that. Next angle I want is angle JHM. Angle JHM. Alright, so which angle is that? Angle JHM. So they want this angle now. So this one kind of easy because it is opposite the 52, right? So that's the cyclic quadrilateral, right? So it's equal to 180 minus 52. So this angle is equal to 180 degrees. 180 degrees minus the 52 degrees. How much is that? 128 degrees. We can write the reason. Opposite angles in a cyclic quadrilateral, you can say cyclic quad, are supplementary. Supplementary means that they add to 180 degrees. Supplementary means that they add to 180 degrees. So that's the reason for that. So we're giving them some reason. You know, just one mark for it, right? I think they will check with the calculation for this one. All right, anything else? No, that finishes that. We did this question already, right? So we can copy these down and paste them over here. Let's copy this from this side and let's paste it over there. Come on, come on, come on. And let's paste it over here. So we can share the file, the solutions, and it's necessary. That's it. All right, we leave it at that. All right, so that finishes the number 2 paper. I'm gonna do the number 3 paper now. The number 3 paper. Number 3 paper is this one, January 2022. January 2022. January 2022. All right, this is it. January 2022. All right. This is January 2022. All right, circle theory. Question says the diagram below shows a circle with points P, Q, R, and S lying on the circumference, and the center mark is Q, is O, right here. It says PR is a diameter, angle subtended by a diameter is 90 degrees, so this is 90 degrees right here. You know that off the bat. And AB is a tangent, that's a tangent. So thinking of tangent and chord, tangent and radius rules. To the circle at P, angle APQ is 3x degrees right here. So they're giving you that. And they're also saying that angle QPR is 2x degrees right here. So you see, I'm just checking to make sure that everything they see is on the diagram. Then I say angle RPS is x degrees. That's right here. Just checking, make sure everything they see is on the diagram. And then angle QSP is 54 degrees inside here. All right, a lot of angles. Question said, determine each of the following angles, show detailed work and where necessary, or where possible, and give a reason. Give a reason. So you see, when they want a reason, they leave a space for it to write the reason. So when they don't leave a space, you know, they don't need it. But I think it's best to just write the reason still, if you can. All right, the first angle they want is x. What is angle x? What's the value of x? X. So let's look at it. We want x. All right. So I guess there are many ways to find x, right? But I'm going to say, okay, this angle 54 is subtended by this chord. The chord is making an angle of 3x with the tangent. See that? So this angle is also 54. See that? But the angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference. But you can see that? So 3x equals 54. Sir. Yes? Somebody said, sir?
Yes, sir.
Oh, you agree?
Yes, sir. That matters.
Okay, good, good, good. But I agree with that? All right. So the angle 54 degrees, which is the only angle that we know, is subtended by this chord that happens to making an angle of 3x with the tangent. So 3x equals 54. So you divide 54 by 3 to get x, right? So let's do it. To get this, we're gonna say 3x, and so we'll just find the value of x, right? Because it's x degrees, so let's find the value of x. 3x equals 54. 54 divided by 3 is how much? So x equals 18. X equals 18. I'm gonna write the reason. Angle between, all right, BET, like that for between. I can spell it out. Angle between tangent and a chord equals angle subtended by the chord. If you want to complete the statement, you will say in the alternate segment of a circle. But if you just write this, they'll give you your marks. And that's the reason why 3x is equal to 54. So x is equal to 18. So now that x is equal to 18, we basically know all these angles now. We know so this is 36, and this is also 18 in there, right? So we know those angles now. What else I want us to find? X is equal to 18 everywhere. All right. What else I want us to find? The angle y. I want us to find the angle y. All right. So I want to find this angle y. Now this angle y is equal to this angle z, don't it? Because they are both subtended by this chord. Again, angle y is equal to angle z. Now, can we find angle z? Yes, because we have the 54 here, and this is really 3x again, you know, so this is also 54 now, don't it? That is inside this is 3x, x plus 2x is 3x. So that's also 54. So this 3x right here, because this 3x is 54, then this 2x plus 3, this 2x plus x is also 3x, which is also 54. And so this triangle is an isosceles triangle. Even though it don't look that way, that's why the question normally said not drawn to scale. Right? And so we can find this angle up here now, the Z, becomes 180 degrees minus 2 times the 54 degrees. And this angle Y happens to be equal to the Z. See that? Did they ask us for the Z separately? Let's see. They asked for the Z separately, you know. You know what? You know what that means? They want us to find the Y another way. Right? That's what it means, you know. If they ask us for the Z separately, it means that they want us to find the Y another way. Let's see another way to find the Y. Let's look at it. Diameter rule. This triangle. This is 90 degrees, right? So these two angles complementary. All right, good. Thank you for that. So that one will work. All right, so somebody said that because this is a diameter, then this angle down here is 90 degrees. So it means that these two angles are complementary. So the angle up here is 90 minus 80. So the x is 80. All right? So we can find it that way as well. All right. So that's what we do. I think that's the way they want us to find. So this angle equals 90 minus 18. 90 minus 18 is how much? 72. I want to put it on the degree because notice the question gives you y degrees. Y degrees. So the y is just a value. Y degrees. All right? So we're going to tell him that it's because this angle is 90 degrees, right? Oh, let's tell him that. So we're going to tell him that angle RSP is 90 degrees. That's the reason. Reason that angle RSP, angle RSP equals 90 degrees. And the reason that it is subtended by the diameter. And then no, the reason why this is 90 minus 18 is that x and y are complementary, don't it? X and y are complementary. They are complementary angles. They add up to 90 degrees, right? And that's how we get this calculation. So you see, you could have found it another way, right? But then the y now, the z now is equal to the y, right? Because they are both subtended by this chord. Right? So I was using a more difficult way to do it. So the z is equal to the y. Down here, the z is equal to the y, which is equal to 72. They are subtended by the same chord. Reason, angles subtended by the same chord in the same segment, angles subtended by the same chord in the same segment. They are in the same segment, Those angles are equal. That's it. We could just write this, you know, we could just say angles in the same segment are equal. Right? We have said that. That finishes that question. So not a lot of work. All right? Very good. Online.
Yes, sir.
Yes, sir. Yes, sir.
All right, let's go to the number 4 paper. So remember, skipping over the number 5 paper, but we did full already, right? So we're gonna go to the number 4 paper now. The number 4 paper. Number 4. So we're talking. Number 4. Wrong way. All right, so this question had a problem. This question is inconsistent. The angles in this question are inconsistent. So this was an error question on the exam paper. If this angle is 68, then it means that angle is angle between this tangent and this chord, this chord must subtend the same 68 up here. So this angle up here would have to be 68 as well. But then this would be a straight line. Total angle on a straight line is 180, and these two right now not added up to 180. So the 68 is inconsistent with 106. See that? Well, suppose you meet at a situation like that in the exam and you realize that it's inconsistent. What would you do? Huh?
I would complain.
No, but guess what? Invigilator is just a random person coming there to supervise you. Well, let me tell you what I would do. I would choose a correct angle. I would make one of them, I would make the diagram consistent. And I would say 68 degrees is not correct.
We can leave it there, right? Just move on to the next
No,
question.
68 degrees is not correct. I'll put what it is. Has to be 74. Must be 74 degrees. Must be 74 degrees. Because I want my marks in a chance. But no, but if you don't realize it, and you go on and give the answers that you get, CSEC have to give you your marks. Even if them wrong, you have to give you your marks. You understand me? And what they might actually do is they might just not bother mark this question. Or they might just assume that based on what you did, you would have got the correct answer based on the values that are there. You understand me?
Sir.
What I would do, yes?
Sir, so why would you do the question anyway if you're going to get, if they're not going to mark it?
I'm doing it just to see it. And I don't want them to don't give me a mark because I didn't do it.
Sir, I'm just move on, yeah, sir. Waste of time.
I still expect you to do it, so just do it. So I'm going to put it at 74. Because 74 degrees make it consistent with the 106. And then I'm going to work it with the 74. That's what I would do. I would say 68 not correct. It has to be 74. Only way it has to be 74. Is that I change that or you change this one? You understand me? If you leave the 64, if you leave the 68, I will change the 106. All right, let's say I change the 68. I'm going to answer the questions. See? A human being marking the paper and not a machine. Just remember, guys, human beings, sometimes it's the same teacher who teach in class. People you pass on the road, people who drive on the bus. Normal people marking the exam paper. They've asked me to mark exam paper many times. I said, no, I'm not time. I know people, a lot of persons who mark exam paper. I know a lot of persons. Normal human beings. They don't feel like it's anything magical. There's nothing magical about it. And that's why they make mistakes. Because human beings do it. Human beings set the questions. And that's why some of the questions are stupid. Because they set stupid questions sometimes. You understand me? Just remember, it's not no robot and not no machine. And it's not no super brilliant, super bright people sometimes either. It's normal people marking the exam, normal people.
There's all homeless people too.
Jesus. No, man, I wouldn't go to that level. Come on. But usually teachers, just teachers, right? And what they do, they hire some teachers to write questions for them. That's what they do, you know. They hire persons to write questions for them, you know. And they send in the questions to them and they get paid to write the questions. Normal people do all of these things. And sometimes they just copy the questions from other exams, like from the GCE exams, or they might copy it from some book. A couple questions as well. Okay? So there's nothing magical about it. You don't want anybody to think that this thing is anything magical. It's normal day-to-day life thing. Just that you have to do it and get them right? Good. So just if I write this on the paper, just know that somebody, a human being, is going to see that. Right? And they say, wow, this person is brilliant. Wow. This person is brilliant. And just give it a marks. Well, let's do it still. Let's do it. Let's assume that they gave us the right thing, and we're going to do it, right? Question said, determine the value of each of the following angles, show detailed working where necessary, and give a reason. All right, the first angle I want is angle ECD. Angle ECD. Angle ECD. That's this angle up here, the one. Angle ECD. Now, remember they told us that some lines parallel, don't it? this line and this line parallel, don't it? So if you look at it, then basically this is a Z, you know. Look. It's a Z, you know, don't it? See that? So this angle is alternate with this one, see it? So that angle is 74 as well, see it? Z angles are equal. Remember now, once you have the parallel lines, you have to look out for the Z angles. These two lines parallel. The same line come all the way back here, so you know. And this parallel line come all the way back here. So you have a Z inside here, so see there? The Z. That's a Z. So this angle and this angle are alternate to each other. They equal the same. Good? Cool? All right. So it is 74 degrees. That angle up here is 74 degrees. So I'm going to just write it. This angle equals 74 degrees. Why? Because alternate, which are called Z angles, are equal. Alternate Z angles are equal. That's it. All right, so put on the diagram as you find it. Put it on the diagram as you find it. So this angle is 74 degrees. You find the angles, you put them on the diagram. Next angle I want is angle CEG. Let's look at it. CEG. Angle CEG. So CEG up here. I want this angle. Easy. That's easier, easy angle. So what we have here now is that this is a diameter and that's a tangent, don't it? Angle between a tangent and a radius is 90. This whole angle is 90 degrees, don't it? So the piece that we want inside here, that I want, must be 90 degrees minus a 74 degrees. Everybody get that? 90 minus 74. But the angle between the tangent and the radius is 90, and this piece of it is already 74. So the rest of it must be 90 minus 74. But I go to that one online.
Yes, sir.
Good.
Yes, sir.
So this angle that I want is 90 minus 74 degrees. Angle between tangent and radius. This angle is 90 minus 74, which is how much? 16? 16 degrees. And the reason is that the angle between a tangent and a radius. Tangent and a radius. Of course, the diameter right here is 90 degrees. I will subtract the 74 because part of the angle is 74 degrees, right? That's it. All right. Next one I want is angle CGF. Let's put on our 16 degrees first. Everything you find, you put on the diagram. So right here, so it's 16 degrees. 16 degrees right here. And the angle that I want next is what? I want angle CGF. Angle CGF. Let's look for it on the diagram. CGF. 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 So I want this angle right here. Right? So what we can do is complete the cyclic quadrilateral. So the angle that I want up here, which I'm going to now mark in red, is supplementary with all of this angle that I'm marking in red. But I said that? Yes. So if we can find this single piece right here to add to the 16, then I would have that angle. All right? It's the same 16. All right, I'm missing off. We're still 16. Let me just confirm that it's still 16. So you're saying it's still 16. Why are you saying it's still 16? All right, let me see. So you said this is 90. That is 90. But how do you know that this is 74? It is 74. Let me show you why it is 74. Because you have this parallel side, right? It's a transversal line between them, right? Joining them. These two angles are co-interior angles, don't it? See that?
Yes, sir.
Good. So it means that this angle down here is indeed 180 minus 106, which is the same 74 degrees. So he's correct. The angle inside here is also 16 for the same reason. Huh? Which angle? Over here, so? So and so and so. All right, I don't know what to say. But this is 60. We agree that it is 60, right? So that is 16. So the angle across here says 32.
Sir, you're saying that it's on an alternate segment.
He's saying that it's a what? Alternate, you mean this way?
Alternate segment, yeah. No.
Alternate segment. Alternate
Yes,
segment.
sir. Alternate segment.
Oh, right. That's another way you could get the 64. Good, good, good. All right. For those who don't say, I didn't see it a while ago. So what he's saying is that this angle up here is subtended by this chord. And the chord is making this angle with the tangent. So this angle out here must be 74 like that. That's what he's saying. All right, yeah, man. Can work that way as well. So usually there are many different ways you can find angles. That's what you see at the time, right? All right, so this angle inside here becomes 32 degrees. So the angle that I want up here becomes 180 degrees minus 32 degrees. Opposite angles in that cyclic quadrilateral. Very good? This purple
Yes, sir.
quadrilateral. Good. All right, so let's just write it. When I tell them that this angle is 16 first. All right. So trying to find this one. So we can tell them what it is and then show them the breakdown. It is equal to 180 degrees minus 2 times 16 degrees. 180 minus 32 is how much? 148. 148 degrees, right? Opposite angles. Opposite angles in the cyclic quadrilateral add to 180 degrees. They are supplementary. That's the reason. You want to tell them how you get the second 16, fine, but you would have indicated it on your diagram right here. Right? You'd have indicated it on your diagram right there. Right? Or you get the 16, and they will accept that as well. All right, I think that finishes this question. Yep. Let's go to paper number 6. We did paper number 5 yesterday. So let's look at paper number 6. Paper number 6, which is January 2020. January 2020. All right. Going the wrong way. Going this way. Let's see, there are circuit theory on every exam paper. Every exam of a circuit theory on it. All right, this question says, the circle shown below has a center O and the points A, B, C, and D lie on the circumference. It says a straight line passes through the points A and B, and the angle CBD is 49 degrees. So everything that they're talking about is on the diagram, right? Then angle OAB is 37 degrees right here. So everything that they have set up here is on the diagram. So we don't need to read up there again. It says write down the mathematical name for the straight lines BC and OA. BC, what's the name of BC? BC is a what? This line. What's that line called?
A chord, sir.
Chord. Simple as that. OA. This line OA, what is it called?
Radius.
Radius. Radius. So the radius have two meanings, you know. Radius is a physical line from the center to the circumference, but radius is also the length of that line. So the word radius has a double meaning, right? It means a physical line. It also means the length of that line. The radius of a circle is also the length of that line. any line that runs from the center to circumference is also called a radius. Same thing with diameter. The line across the center from circumference to circumference is called the diameter of a circle. But the length of that line is also called the diameter. Get me? So sometimes some words have some double meanings in these questions. But anyway, can we identify some features before we start? Like for example, this is an isosceles triangle, don't it? Because this is a radius and this is a radius. So therefore it means that this angle down here is 37 degrees. Like this one, don't it? And so we can find angle X. That's all. And then now, this angle down here is subtended by this chord, but it's at 90 degrees, don't it? It's at 90 degrees. So them two angles are complementary, no? That's all? So we can find Y by doing that. I think that's it. There's only two angles in there that we don't know. And that's only two angles that can maybe ask us for. Determine the value of each of the following angles, show detail work where necessary. Give a reason for your answer. The one angle X. So we're gonna come and say that this angle, this triangle is isosceles. And the angle is 32. I'm gonna put on the diagram now. I'll leave it now. I'm gonna say this angle is 37. I'm gonna tell the examiner that angle is 37 by putting it on the diagram right here. This is 37 degrees. But the triangle is isosceles. And therefore the X is 180 minus 2 times 37. That's all? All right, so I'm gonna say the X is equal to 180 minus 2 times 37. 2 times 37 is how much? 74? 2 times 37 is 74, don't it? So this is 106. 106. All right, and should I put a degree on it? No, because the question said X degree, so X is just a value. You don't need a degree on it. X is just a value. What's the reason? The reason that that triangle is isosceles, no sir. And the total angle in the isosceles triangle is 180, don't it? So can I write it here? Total angle in, I was stating that it is isosceles right now. Isosceles triangle. Which one is it again? The isosceles triangle here is OAB. In isosceles triangle, OAB. We're telling examiner that it's isosceles. OAB. That total angle is 180 degrees. And that's why we're using the 180 right here. I was saying the isosceles, that's how we're multiplying that side, that angle twice. But it's the isosceles. That's it. You want the angle Y. So for the angle Y, again, we're gonna say that this angle is 90 and these two are supplementary, right? So we can say this angle Y is 90 degrees minus 49 degrees. How much is that?
41.
41 degrees, all right? So I tell the examiner that this is a right angle triangle. So I tell him that this angle is 90 degrees. That's subtended by the diameter. I have to give the reason. So the angle BCD. Angle BCD is 90 degrees. So this angle becomes 90 degrees minus 49 degrees, which is 41 degrees. What's the reason? Because angle BCD is BCD, make sure. Yes, BCD is 90 degrees. Angle BCD equals 90 degrees because it is subtended by the diameter. That is why it is 90 degrees. Diameter. And then this now, because these two angles are complementary, right? So we can write here, complementary angles. They add up to 90 degrees. Complementary angles. They add up to 90 degrees. So we're stating that those angles are complementary. Two remaining angles in the triangles, they add up to 90 degrees, right? That's it. So that's finished the circuit theory, guys.
So
Yes?
you could just repeat why you said the ABC, that angle was 37, like the rule that you called out.
This one?
Yeah, is it because, oh, it's okay, yeah, you can repeat it.
Why this one is 37?
Yes, please.
Because this triangle is isosceles. The reason it is isosceles because this is a radius and this is a radius.
Oh, right.
Yeah.
Okay, yeah, right. Okay.
Good. Remember, a sector triangle is always an isosceles triangle. Why is that called a sector triangle? Because it is an angle in this sector. It's a triangle in this sector, I mean.
Okay,
See?
sir.
So a sector angle in a sector, a triangle in a sector is always isosceles. And it's basically when it's formed by the chord. See? Two radii and a chord. In the form of that triangle, it's called a sector triangle. It's always isosceles because of radius and the radius equal. You good? That's okay?
Yes, thank you.
Yes, sir.
All right, cool. All right, so that finishes that question. So we'll finish circle theory now. Which topic we going to do next? Let's do the number 6 question, which is the measurement. Let's go on to the measurement questions. All right? Huh? The measurement question like volume and area and solid geometry and all this. Right? Number 6. All right? All right, let's start with the number. Since we're on this video, let's go to number 6 on this one right away. So we're going 6, 4, 3, 2, 1, right? So we're going to number 6. Number 6 on this video. So we're doing the number 6 questions now, guys. We're going to come on to the pattern questions as well, you know, eventually. I don't know if it's today. We're going to do the pattern questions as well. We're looking at the number 6 questions. Measurement. Teacher, bam. Love it. Ready? Let's go. Think about the number 6 questions, you know, they tend to be different from paper to paper. Right? They tend to be different from paper to paper. Just a work what to get it from. Sometimes it's solid geometry, sometimes it's plain geometry. Right? So it's geometry. All right, it says, sometimes it's circles, see? And this one has some circling. Question says, the radius of each circle in the rectangle WXYZ shown below is 7 centimeters. See? The radius of each of these circles is 7 centimeters. It means that the diameter of each circle is 14, don't it? The diameter is 14. It says the circles fit exactly in the rectangle. So this is 14, 14, 14, 14. Then the length across here says 4 times 14, don't it? 4 times 14 centimeters. And then down here now you have 14, 14, 14. So the width of it is 3 times 14 centimeters. But I give it that?
Yes, sir.
Figure enough sort of thing before we do anything, you know. So this side becomes 3 times 14 is how much? 42. And 4 times 14 is how much? So this side is 56. Before we start doing anything, we're figuring out this stuff. So this length is 56, and this length is 42. I can leave all these markings on the diagram on the paper. And the examiner see how you get the stuff. Leave them on the diagram. Question says, show that the area of the rectangle is that. So I leave these markings on it. I show how I get the 42 and the 56. I'm going to say the area becomes equal to 56 times 42. Equal that, don't it? Somebody can check it and tell me. What I'm saying, the area of the rectangle. Right. Check it for me. Is it equal to 2,
Yes,
3,
sir.
5, 2
Yes, sir.
centimeters squared? Beautiful. So easy that was. Nice and easy. Good. Let's continue. Them questions are always a common sense, you know, most times. Common sense. You look at it and see what it's like. Right? It's not difficult. Question says, calculate the area of the shaded region. Take pi as 22/7. Let's look at the diagram now. How are we going to find the area shaded inside? Let's take out these marks. How are we going to find the area shaded inside here? We're going to find the area of one circle and multiply by 12. There are 12 circles there, don't it? That will give us the area unshaded, and then we subtract that from the overall area, don't it? So
Yes,
can
sir.
we write it and say, okay, it's the area of the rectangle minus 12 times the area of one of the circles. Can we say that? There are 12
Yes,
circles
sir.
there, don't it? All right. So we're trying not to use too much space enough. So the area shaded, let's write it this way. Let's write it this way. Area shaded equals area of the rectangle minus 12 times the area of one of the circles. But I give it that? Area
Yes,
of one
sir.
of the circles. Good. So the area of the rectangle, we know it already. It is this figure here, so 2352. 2352. 2352 minus 12 times. What's the area of a circle now? Pi r squared. Can we just write a little pi r squared? Examine us right here, so pi r squared is the area of one circle. You can put on a paper like that, you know, no problem. And then we're just going to do the calculation here now. The pi is 22 over 7, 22 over 7 times the radius was 7, don't it? 7 squared. And just drop that in the calculator. You don't have to work out this side, you know. You don't need to work it out. Just put everything in the calculator one time. Somebody can do that for me?
104.
How much?
504.
504. All right. 504. Make sure you write the centimeter squared on it. 504. What a good?
Yes, sir.
All right, beautiful. Next question. 3 marks for that. Oh, that question. Oh, part B. Yeah, we're doing all of these question 6, right? So part B looks like a tricks question, but some easy tricks, right? Section 1, right? That no sine rule, cosine rule. No. This question says, diagram below not drawn to scale shows triangle M and P in which MP, angle MPN is equal to angle PMN is 52 degrees. That's showing it right here, 52 degrees. So it means that isosceles, don't it? It means that a side here and a side are equal, don't it? Put it on the diagram. Don't even bother waste time. As you know something, you put on the diagram. So this is also 12.5 centimeters, don't it? So I have an isosceles triangle. And can we find this angle here, son? In case you need
Yes,
it.
sir.
Because it's 180 minus the sum of those two. Some of these two is 104, don't it? 52 plus 52 is 104, don't it? So this
Yes,
angle
sir.
right here, let's show the working. This is equal to 180 degrees minus 2 times 52 degrees. Because total angle triangle is 180. What does it work out to? Let's write it in here when you work out. How much?
76.
74.
30 much? How much? 76.
76.
Yes, sir.
76. I'm not working it out. You work it out. All right. I just not here
76,
anywhere.
sir.
76 degrees. Next part. State the type of triangle that is. What a free mark that is. What is it? Isosceles. Isosceles. It's an isosceles triangle. Determine the value of angle P and M. We worked it out already, you know. It's 76, don't it? It is equal to 180 degrees minus 2 times 52 degrees. It is 76 degrees. What an easy question. Next part. Calculate the area of the triangle. So now it's not a right angle triangle, don't it? So we're not going to use a half base times height, right? We're going to use the formula that says half AB sine C. For those who don't remember, if you have a triangle and you can't get the perpendicular height and the base to get the area, but you have two sides and an angle between them, let's call it theta this time, the area is half the product of the two sides times the sine of the angle between them. What go to that? You have to remember that formula, guys. We call it the trig formula for the area of a triangle. That's what I call it. The trig formula for the area of a triangle because it has some trigs in it, right? It has a trig in it. So that's what we have to use. So we're going to use these as our two sides and the 76 as our angle between, right? I can leave this for an exam paper to me. Examiner see how you get it now. I'm just gonna calculate it now. And this formula is on the formula sheet, you know. This is on the formula sheet. Let's look. On the formula sheet. Let's look. Let's look on the formula sheet. Where is it? See it down here, sir. Where is it? See it here, sir. See it here, sir. Now. That's it. Half AB science. So if you don't remember, it's on the formula sheet, right? And there's this one. There's also this one, but this one hardly ever get used. That one hardly ever get used. Right? Hardly ever get used. But let's continue still. Where are we? Number 6. Number 6, right? Number 6. Let's continue. Let's continue. We'll do some statistics as well. All right. So we're going to apply that formula now. So the area of the triangle will be equal to half. Product of the two sides. Just the two of them are the same, right? So it becomes 12.5 squared. 12.5 squared. Times the sine of the 76 degrees between them. And they write equal and calculate it. Someone can calculate it for me and tell me what they get.
75.8.
How much?
75.8.
75.8. Make sure you write the centimeter squared for me, please. Don't leave out the unit. All right? That finishes that question. Let's go to the number 4 paper. Number 4 paper. Let's go to the number 4 paper now. The number 4 paper. All right, it's now 6 o'clock. We're going to take a break at 7, right? All right, so let's work for another hour and then we'll take a break. All right? Because we're really only working for, how long are we working for now? Hour and a half? We started at 4:30. All right, so we can maybe stop at 6:30. Take a break at 6:30. All right, number 4 we're at now, right? Paper number 4. Paper number 4. Remember, this is revision, guys. Just working this over, refresh your memory, build your confidence, clarify anything that is not so clear for you. All right, if there's anything to learn, you learn it. All right, number 6. Number 6. See, always some measurement question. Number 6. All right, let's go. This question says, Farmer Brown makes troughs to feed his animals using wood that is 5 centimeters thick. So it means that this is 5 centimeters thick up here. Everywhere is 5 centimeters thick. All right? It says, as shown in the diagram below, the troughs are rectangular based. So you have a rectangular base and an open at the top. Open at the top. And it has external dimensions, 300 centimeters, 190 centimeters, 160 centimeters. Those are the external dimensions. Good? Remember, the material is 5 centimeters thick, you know. So if these are the external dimensions, can we write down the internal dimensions? We're going to need them. Let's look at it. So if this side is 5 centimeters and this side is 5 centimeters, then we're giving up 10 centimeters across for the internal dimension, right? Internally, right? Across. So across here, across here is going to be 300 minus 10. But I get that? So it's going to be 300 minus 10 across here, internally. 300 minus 10, that's right. Across here, internally, it's 300 minus 10, which is 290 centimeters. But I give it that. Let's put 290. And then now, giving up 5 centimeters at this end and 5 centimeters on that end as well. On those sides, right? And overall external is 190. Externally, right across is 190. Right across end to end, external is 190. You're giving up 10 and 10, right? So internally here, this way, let's use a different color. It's going to be 190 minus 10, which is 180, don't it? So this is 180. Then let's talk about the depth now, the depth of it. Internally, this is a different color for the depth, internally. So externally, the height of the box is 160. Remember, only the bottom is closed. The top is flat and there's no cover on the top. So the thickness, you're only losing the thickness at the bottom down here, don't it? Internally, don't it? Which is 5 centimeters. So internally, the depth is 155 internally. The depth is 155. All right, so let me make a little adjustment. Let me shift this down a little bit. Let me shift this down. Let me shift this down. I want to shift this down. I'm just driving. So I want to show the depth of it internally. So I'm going to put this right here instead. Across here. We say that is how much? 10 off of that, which is 290, right? 290. And then we're going to show the depth in purple. Down here, internally. We're taking 5 off the 160. Why? Because it's only the bottom that is closed. The same thickness of material. Just imagine a draw. Right? So you're taking out the 5 centimeters of the bottom internally. So this is on 155 internal. So what I've shown here are the internal dimensions. Those are the dimensions internally. Inside the space in the box, right? Or the trough. Show by calculation that the internal capacity, which is the internal volume, is equal to this. We need to multiply these values, don't it? I'm in the exam, I'm going to leave these markings on it, and just use the values down here now. I'm going to leave those values on it. And I'm going to write that capacity, internal volume, as a volume internally, is equal to 290 times 180 times 155. You must get this figure. 100% sure that you're going to get that figure. 8091,000 centimeters cubed. Somebody can check that for me, that's correct? Check it for me. Multiply that.
Yes, sir.
Good. But I understand that so far? Nice and easy. It's almost like common sense. Because you can visualize it, you can see. That's the beauty about these questions, you can visualize what they're talking about. All right? You can literally see it. Next one. Calculate the volume of wood needed to make the trough. How are we going to get the volume of wood to make the trough? So it's the volume of everything externally minus the space inside, which is the internal volume. That is how the wood volume is remaining, right? But I understand that. So the external
So you mean like the volume of the thickness?
Huh?
We're talking about like the thick part that's 5 centimeters thick all around?
Yes, 5 centimeters thick all around. Yes, because that's what they said. They said it made of 5 centimeters using wood of 5 centimeters thick. So it's all around everywhere. The wood is
So we're trying to find the volume of that minus the interior.
No, man, we don't have to do that. Find the volume externally and subtract the volume, the internal volume. That leaves with the volume of the wood. That's the easy way to do it. All right, you have the internal volume now, we know. So you just need to calculate the external volume and subtract the internal volume. That will be the volume of the wood. Right? So that's it. So the volume of wood, let's write it this way. The volume of the wood would be equal to the volume externally, the external volume, minus the volume, internal volume. What's the external volume? External volume is calculated using the external dimensions. The 300, the 190, and the 160, don't it? See that? 300, 190, and 160. So this becomes equal to 300 times 190 times 160. And then subtract the internal volume that we have here already. This one. 91,000. 91,000. 91,000. Somebody wrote that out for me and tell me what you get. I don't need to see this, you know. Just Just word that out for me and tell me what again. This is going to be the external volume, the volume of everything, including the wood and this and the internal space in the box. When you subtract the internal space in the box, you're going to left with just the wood, the volume of wood. What does work out to? Somebody work out and tell me.
1,029,000.
Give me digits. Give me digits. 4. How much?
1,029,000.
Good. cm cube. Don't forget to put on the units, guys. Volume. That's the volume of wood. That's the volume of wood in this box. But I understand that? Everybody good online?
Yes, sir.
Yes, sir.
Yes.
And the class, everybody good in the class. All right. Next part now says, Farmer Brown must paint the internal surface of the chalk. But the internal surface is these now, you know. Those dimensions, you know. These are the internal dimensions, you know. Right? Those are the internal dimensions, right? And how many sides you have internally? The 4 walls and the base, right?
5.
Right, the 4 walls and the base. All right. Let's see. All right. Given that 1 gallon of paint covers 280,000 cm cube of surface, determine the total amount of paint, and I want it in liters, that is needed to paint the internal surface. So what we have to do now, guys? We have to find the total internal surface area and then divide it by this amount. Because we know that every gallon uses this amount, and that will tell us how many gallons we need. And then we know how many gallons we need. We use this to convert it into liters. But
So liters is sorry, one liter is equal to 1,000 cm cube.
If we can do what? We're not gonna work in meters. No, we don't want to change the unit. We're gonna just work in cm cube, centimeter squared. This is asking for liters, and it gave us a conversion between gallons and liters. Right? So all I'm saying, since this amount uses 1 gallon, we're gonna find out what the total internal surface area of the box is. And we'll divide it by this. That will tell us how many gallons we need. And then when we see how many gallons we need, we use this conversion to get it into liters. Because the question wants us to tell them in liters. Simple as that. All right? Or we could recognize is that this 1 gallon is actually 3.79 liters. We'll do that as well. But let's get it in the gallons first. So the question is now, what is the internal surface area of the box? Internal surface area, that's all we need to do. So the internal surface area. So let's call it area internal. Let's just call it that. Area internal equals, we're going to add up the areas now. There's a quick way to do it. You put the perimeter around this n times the length of it. But let's say we add up the areas. So we have two short sides. So we have two sides that are 280 by 150, don't it? The side internally here is going to be 290 by 155, right? And the side internal over here is going to be 180 by 155, don't it? And then the base internally is going to be 290 by 180 internally. But I get that? All right, so that's common sense. This is not hard common sense. We'll add up the sides step by step, all right? All right. So we're going to have the two sides that are, let me copy it down. Let me see if we can copy it down. So is it, let me copy this down. Let me copy this down so it's in front of us. Let's copy this down. Copy, paste it down here. So we have the values looking at. Let's paste it right here. All right. So remember that the purple is the depth of the box, right? The vertical height of the box, internal, right? All right. So this volume is going to be 2 times 2 walls that are 290 times 155. don't it? Again, 2 walls plus 2 walls that are 180 by 155, don't it? So those are your 4 walls, you know? Plus the base, which is 290 by 180. That's the base. So these are 2 walls, 2 long walls, 2 short walls, and the base. But I go to that, I just add up everything. Them on again. I would have a lot of space to work it out. So let me move this. Let me move this. We don't have a lot of space to work it out. That's one of the issues with this. You know. That's why you must know that you can't write too much on the exam paper, guys. You don't get a lot of space.
250,000.
How much? Somebody gets something different. What all of this equal to?
Sir, 250,100.
All right, let me do it myself.
Let's see that.
Let me do it myself and see. Adding up all of those areas. All right, let's see. I'm going to add up everything. So it's 2 times 290 times 155 plus 2 times 180 times 155 plus 290 times 180. 197,900. 197,900 centimeters squared is the area internally. Good? So what is now? Paint required. So remember now, 1 gallon use this amount. So if you want to know how much gallon this use, how much gallon this you want, divide it by the 280,000. That's all? That's all. So I'm paint required. Let's do it this way now. So paint required. Paint required is going to be the amount that you're covering, which is 197,900 divided by the amount that does 1 gallon, which is 28000. That's the amount of paint that you need. Another 0. You need another 0. 280,000. And that's going to tell me how much paint I need. So it's 197,900 divided by 280. 1, 2, 3. 28. So I need 0.0. See if we can get to that fraction. Let's see. No, we'll get to that fraction. I'm going to put the decimal. So I get 0.707, 3 significant figures. 0.707. Make this a little bit smaller. Make that a bit smaller so we get space to go over. All right. 3 significant figures. Work with 3 significant. When the answer is not exact, work with 3 significant figures. So correcting that to 3 significant figures becomes 0.707 gallons. But I want to answer in liters, and 1 gallon equals this. So therefore, this amount in gallon, if you want it in liters, we have to multiply it by this amount, the 3.7, don't it? So it becomes equal to 0.707 times 3.79 liters. And this is the answer right here. So multiplying this answer, in fact, since that is in the calculator, just multiply it right now by the 3.79. I will get 2.68, 3 significant figures. 2.68 liters is the paint required. 2.68 liters. Any questions there?
No, sir, not really.
Good. Them questions are real life questions and common sense. Real life question. Just think of it logically. Don't bother think of it like in an abstract way. Think of it realistically. This amount of paint, this amount of surface area is use 1 gallon. And the surface area that you're doing is actually this. I want how much paint to use. They divide it by the amount that does 1 gallon. Right? And you see how much you pay, how much you need. So you need this amount of paint. But they said that they want it in liter. And I see it makes sense, right? Because this amount of air that they cover is less than the amount of 1 gallon though. So you must need less than a gallon of paint, don't it? See it? So it makes sense, right? Must make sense. All right, so that is good. That is okay. All right, so that is the paper 4. Let's go to the paper 3 now. Paper 3. Paper 3. We'll do the number 6 on paper 3. So maybe we can break after we finish that set of questions, right? Let's have a short break, like 10 minutes. When I come back, I will start with maybe number 8, maybe number 7, or maybe number 5, statistics. Then do some statistics, yeah. Some number 5. Paper number 3. We don't want to leave too much for tomorrow, you know. Tomorrow is the day for the exam. Plus, people have exam tomorrow. Like some persons have English tomorrow, right? So we don't want to leave too much for tomorrow. Right? We don't want to leave too much. So the more we can finish off today is the better. We want to cover all the topics on the paper in this little revision. We want to cover all the topics, even question 1. And the consumer arithmetic in question 2, question 1 and 2. We want to cover them too. Looking for number 6. We're looking for number 6. So one of the statistics, one of the pattern questions. We want to cover all the questions in these 5 papers. All right, see it here? Yes. See it? Them kind of question again, measurement question, right? In number 6. Number 6 is always some measurement business. All right. And remember, now, just think of it logical, it's not complicated. Just think of it like real life. I'm always bring some real life things to the question. This question says, at a track meet, a cylindrical container fitted with a pipe, as shown in the diagram below, is used to serve water to athletes. The cylindrical container of radius 12 centimeters and height 20 centimeters is completely filled with water, and the pipe fitted at the bottom dispenses water into cone-shaped cups. Stop talking on both sides. So this is our cylinder, and the dimension that we talk about up here is shown on the diagram. So we have to go back and read it up here. So it's on the diagram. These are your cone-shaped cups, and they give you the dimension. It says the shape, it says the cone-shaped cups have a radius of 3 centimeters, so 3 centimeters there, and a height of 8 centimeters, so the height of 8 centimeters there. So everything they gave us in the wording up here is in the diagram. And I like that. It means that I don't want to read nothing again. Anything I want, information is on the diagram. Okay. Question says, calculate the volume of water in the cylindrical container, and I want it in liters. Write your answer correct to 2 decimal places. I remember that 1,000 cm cube equals 1 liter. 1,000 cm cube is 1 liter. So because they gave us the dimension in centimeters, we're going to calculate the volume in centimeter cube first, and then we're going to divide it by 1,000 to get liters. Good? We have 1,000 cm cube equal 1 liter. You want to go from centimeter cube to liter, you have to divide by 1,000, right? So basically, we calculate the volume of this cylinder. Volume of a cylinder is the area of the base, which is pi r squared, times the height. Let's write it here. So the volume of the cylinder, let's put CYL for cylinder, is the area of the base, which is pi r squared, times the height. This formula is on the formula sheet as well, volume of a cylinder. So that's what we're going to use, pi r squared. What did they say to use pi as? Let's see. Did they tell us what to use pi as? No. When they don't tell you what they must use for pi, use the pi in your calculator. Don't round it off. Don't put a 22/7. Use the pi in the calculator if they don't tell you the value to use for pi. Don't put a 3.14. Don't put a 3.142. Don't put a 22/7. Use the pi in your calculator. 3.14 is just an approximation for pi. 22/7 is also an approximation for pi. Pi is what we call an irrational number. Cannot be written as a fraction. But the estimated fraction for pi is 22/7. That's what's the closest fraction to the value of pi. But pi is what we call an irrational number. Cannot be written. The actual value of pi cannot be written as a fraction with a whole number numerator and denominator, as they do when they put 22 over 7. So when they don't tell you what to use for pi, what did I say? Use the pi in your calculator. But that one give you the right value for pi. Cool? Let's continue. So we're gonna do that now. So the volume that I want down here, using this formula, pi r squared h. The volume in the cylinder is the pi in the calculator times the radius, which is 12 squared, times the height, that is 20. And the question said, give your answer to 2 decimal places, but we're going to get it in CM2 first. Tell me what is work out to in CM2. Somebody worked out and tell. Hold on. Go now. 9047.79, and this is CM cube, right? CM cube. But I want liter. So since I want liter, we divide by 1,000. 1, 2, 3, don't it? So when we divide by and put it in liter, we're going to get 9.04779 liters. But the question I want to answer now to be 2 decimal places. So we're correcting this decimal place right here. See? So it's 9.05. We're correcting these 2 decimal places with the 7. So it becomes 9.05 liters. Better go to that. But all right. But online, okay?
Yes, sir.
All right, good. So that is the volume in liters of the cylinder. All right. Let's continue what they want us to tell you. It says, water flows from the cylindrical container along the pipes into the cone-shaped cups at a rate of this, 7.5 milliliters per second. So they're giving us this in liters, milliliters. Now, let me show you something now that is good to know. Something that is good to know. 1 cm cube is 1 milliliter. So that's 7.8 milliliters, what I'm give you is also 7.8 cm cube. All we know say that is true. Because watch this. 1,000 cm cube is a milliliter, don't it? It's 1 liter, sorry, it's 1 liter. It's 1 liter. It's 1 liter, don't it? But also 1,000 milliliter is also 1 liter, don't it? So let me say them two are equal, that's all. The two of them equal 1 liter, don't it? So if 1,000 cm cube is 1 milliliter, then means that 1 cm cube is 1 milliliter. But I understand that. So this 7.8 milliliters that they gave us is actually also 7.8 cm cube. I don't want to be doing the math working in multiple units. Since the dimensions on the question are in centimeters up here, we really want to just be working in centimeters and only bring in the liters at the end if you have to. You get? So I wouldn't want them to give me this rate in liters, but the fact is they give it to me in milliliters, and I know that the milliliters here so is also centimeter cube. So I'm good to go. I can use a CM 7.8. So remember this, guys. I can actually leave it on the exam paper right here. The examiner see that 1 milliliter is 1 cm cube. So this 7.8 milliliter is actually 7.8 cm cube per second. Per second. All right. So we'll establish that first, right? Just wanted to spend some time on that. Watch me now. Let's talk about this 7.8 cm cube per second now. It is not complicated. All it means is that every second they pour 7.8 cm cube. That's all it means, you know. So in 2 seconds, the amount of flow is 2 times 7.8. In 3 seconds, the amount that flow is 3 times 7.8. So plenty of people see this per second business and think of it as something complicated. It's quite simple. All it means is that every second, 7.8 cm cube flow into the cup. That's all it means. So if you want to know the amount that flows in 10 seconds, you multiply this by 10, don't it? But understand that. It's simple like that. All right, that's what I want us to do. It says calculate the time taken to fill one cup. The time taken to fill one empty cone shaped container. How can I get that time then? We can find the volume of one of the cones and divide it by the 7.8. And that's going to give us the time in seconds. But understand that? So
Yes,
let's
sir.
find the volume of one cone cup divided by the 7.8, and that will tell us how long it takes to fill the cup, the cone cup, right? And helping us here, the volume of a cone is 1/3 pi r squared each. They give us that formula. It's good to know, you know. But the volume of a cone is 1/3 pi r squared. So let's work it out. Let's work it out. We need the volume of the cone cup first. The volume of the cone, that's why I thought cone. The cone cup, that's the volume of the cup. The volume of the cup, we said cylinder, now saying cup. Is this formula we use it? What was the radius of the cup again? Radius was 3, don't it? And the height was 8, don't it? No, sir? Don't it?
Yes, sir.
I remember. I want to just read the question, I don't remember what it says. That was a cone cup. See there, the radius is 3 and the height is 8. Working on the cone cup now. I'm going to read it for your bird. Lazy, you know? Lazy. Let's go. The volume of the cup is 1/3. Use the pi on the calculator. The radius is 3, so we're going to write 3 squared. If you could just put 9 times the height is 8. Write that out to the calculator for me, please. That's a volume in 1 cup. Work it out for me. Use the pi on the calculator. And remember, 3 significant figures. 75.4 cm cube. Let's move this over. Let's move this over. Let's write this up here. So the R is 3 for the cup, and the height is 8 for the cup. But I agree with this value? But I get that value?
Yes, sir.
Good. So that's the bottom of a cup. So therefore, the time to fold becomes 75.4 divided by the 7.8. So I say it was important for us to know that the 7.8 milliliters is still 7.8 cm cube. That's why we do the mathematics before the exam. We want to learn as much as we can before the exam. So in the exam, we can give you a question with milliliters. Milliliters, you know, not liters, you know, milliliters. 1 milliliter is the same as 1 cm cube. Good? Can't penalize for advance. Write this out for me and tell me what you get. The time. And them say to the nearest second. What do you mean by to the nearest second? What do you mean by that? To the nearest second. The nearest whole number. Correct it to the nearest whole number, right?
10 seconds.
So you get 9.7 seconds, but to the nearest second,
10, sir.
it's gonna be 10.
Seconds.
You're gonna put 10 seconds. 10 seconds is out of 10 seconds. So it takes 10 seconds to fill 1 cup. Are you good at that? Are you okay?
Yes, sir.
All right. Next question
Yeah.
says, determine the number of empty cups that can be completely filled from the container, the cylindrical container. How are we going to determine that? How many cups you can completely fill? How many cups can be completely filled from the cylindrical container? Who can tell me how we're going to do that? So the volume of the cylinder, I remember I said the cylinder was full enough. The volume of the cylinder divided by the volume of 1 cup. That tells you the number of cups. Agreed? So see it here now, number of cups needed equals the volume of the cylinder divided by the volume in 1 cup. The volume that 1 cup takes up. The volume in the cylinder was how much again? Okay, let's work in the same centimeter cube now. Work in the same cube. How can I work in the liter? Well, this is liters. Yeah, I work in the same cube. Work in the same cube, which is this. Do we know the volume of the cup in liters? No, work in same cube for the cup. See? So we're gonna work in same cube throughout, right? So it's this figure we're using in liters, this one. I'm gonna use that full figure in liters. This is the volume of the cylinder. Copy this down. Let's put it down here. So. Right here. Let me shift this over first. And you divide that by the volume of 1 cup, which is what? 75.4. 75.4 cm cube. How many cups they get? Tell me how many cups they get. Huh? What the character gave? Tell me what the character gave. 119.99. 119.99. So we get 119.99. Know what that means? Me say don't full, you don't reach 120 cups. So the answer is 119 cups. You need a little bit more for full the next cup. See that? So don't bother roll it up to 120. You say how many cups can be completely filled? You get me? So I would write 119 cups. Because the 0.99 are fully full. I'm not getting 120 exact. Right? Because this was the exact value that we got in the calculator for the other one. When we did the volume of this one, this was the exact volume. All right, let's do an exact check. I'm gonna put this exact volume over this exact volume. No correcting, no going with that. Let's just check it, right? Let's just double check that. So I'm gonna put this exact volume up here. Let's copy it down. Let's do an exact check. Copy. And that's the exact volume of the cylinder. Let's put it down here. Paste. I don't like that 0.99 distance. And this is the exact volume of a cup. Exact. This is the exact volume in a cup. Let's do an exact check. Copy. Or divide it under here. Come, put this in the character for me now. This is the exact volume of the cylinder. This is the exact volume of a cup. Write that out for me. 10 more again. That will give me the correct answer. I'm not correct, I'm not round up nothing. Let's see. Well, the pi them cancel, right? The pi's them cancel, you know, so don't need the pi. The pi them cancel each other, right? So don't need the pi. Don't need the pi's. So the pi's them cancel. So if the pi's them cancel, you're going to get a fraction. This is going to be 144 times, this is going to be 20 over, this is going to be 1/3 of 9.
Sure, 120.
Huh? 120 exact. Right, so the exact. Right, so since we do the exact check at 120, so right. So 120 exact. 120 cups. Because if you did it, if the exact check, if you did the exact check and you got for example, 119.7, for example. So you say 119 cups get filled, right? Everyone understand that?
Yes, sir.
119. Good. So that's what I was checking for. So that's why I did the exact check, right? So sometimes you need to do something like that. All right, so that was the exact check. So 120 exact. All right. Paper number, which we're going? Paper number 2 now, right? Paper number 2. We're going to finish this topic and we'll take a break. Paper number 2. Let's finish the topic and we'll take a break. We're going to lazy, so. One German lazy. Paper number 2. Number this. I tell you, better. All right, let's go. This one. Come on, we're going to finish these and we'll take a break. Take a break. We want to leave very few things for us to have to do tomorrow. That's what we want to know. We don't want to have a lot to do tomorrow, right? So we just have a few topics to do tomorrow, like 2 topics or 3 topics. Can finish early and go home early. Tomorrow we can start 4 o'clock again. Can start 4 o'clock tomorrow again, so go home early, right? So I send out an amendment to the schedule. Start early tomorrow. I just say we'll start 1 and but I think some people have exam. I'll decide overnight and let them. All right, ready. Let's go. This question says, the diagram below shows a solid made from a semicircle, cylindrical base with a rectangular prism above it. It's an object with uniform cross-section. There's a volume equals n area times length question, right? All right. Volume times n area times length. It says the diameter of the cylindrical base and the width of the rectangular prism, 4 centimeters. See here, so it's a 4 across here, so 4 across here, so. All right. Now this happens to be a square. Because this dimension is also 4. And if this is the diameter, watch this now. Be careful. Be careful. For this cylindrical base with a semicircle, half of a circle, semicircle. This diameter is 4, so it means that the radius is 2, you know, don't it? Radius is 2. We tend to work with radius when we're doing the circle question, right? So realize that the radius is 2. All right, that's what I'm saying now. Calculate the total surface area. Nice. Remember, total surface area of an object with uniform cross-section is the 2 end areas plus the curved surface area. And the curved surface area, remember, is perimeter of the end times the length. We're going to do it the easy way. Perimeter of the end times the length. The end is this. The end is this. The end here, cross-sectional area. This is the end. This is the end. So you have that, and you have this semicircle down here. So that I've marked in red is the perimeter of the end. Perimeter of the end. So it's 4 plus 4 plus 4 plus 2 pi r will be the circumference of a circle. So it's half of 2 pi r, which is pi r. So this curve on here so is pi r. That's the perimeter of the end. Multiply that by the length, you get the curved surface area, the area around the side of this thing. And then you're gonna add the 2 end areas, this total area and this total area. But I go to that, let's work it out. Let's work it out. All right, ready? So I want the total surface area. Let's write out the formula. Total surface area is a curved surface area plus 2 times the end area. This A means the end area. This means curved surface area. Curved surface area is the perimeter of the end times the length. What is the length of an object with uniform cross-section? Is it the distance between the 2 ends? Is the L. The L is the distance between the 2 ends. Plus 2 times the end area. Let's work out each of these pieces now that we want. Let's work out each of these pieces. Let's write them down over here. In purple. We want to work this out, right? To get the total surface area. Ready? First thing we want is the end area, A. The end area, A, is the area of the rectangle there, which is a square, which is 4 square, don't it? Plus half of a circle. Pi r squared is the area of a circle, but this is just a semicircle. So it's just half pi r squared. Half, what did this much use for pi? Did they tell us what use for pi? Let's see. I always look and see them tell it. Nope. So them don't tell you use a pi in the calculator. Cool? So it's half pi. Remember the radius is 2, right? 2 squared, half pi r squared. This is gonna give me my end area, the A. Work it out for me. Tell me what I get.
6.28.
How much?
6.28.
3 significant figures. Give me 3 significant figures. Give it to me. Give it.
6.28.
6.23.
6.28.
Oh, 6.28. 6.28 centimeters squared is the area of the end. Then to get this, I need the perimeter of the end. The length I know already know. What is the length? What is the length?
12.
The length is the distance between the two ends. 12. 12. All right, 12. So the L is 12 centimeters. Then I need the perimeter of the end now. What is the perimeter of the end now? The perimeter of the end, as I said, is 4 plus 4 plus 4 plus this half of a circumference, don't it? Let's write it up here, so. The half of a circumference here, so. Circumference is 2 pi r. Half of a circumference is just pi r, don't it? That's all. And then up here, this length plus this length plus this length give me 3 times 4. So the perimeter of the end is 3 times 4 is 3 times 4 plus pi r. Pi times 2. But understand that? That's the perimeter of the end of the shape. You get 6.2. You can't be 6.2 because that's a 4 squared of 60. That is correct. You can't be 6.2. So maybe this is 6.2. Oh, add the 16 to it now. Add the 16 to it now. Add the 16. All right, sorry about that. Much is it? 22.28.
Sir, I got that answer too.
All right, so 22.3 then. 3 significant figures. 22.3 centimeters squared. All right. So the person who gave me the answer, well, they only give me that far. That's no problem. That's okay. Add the 16. All right? Ready now. Finish this for me now. But that's on this calculation? Yes, sir. But that's on this calculation, right? This is a 3 times 4. We're trying to get the perimeter of the end. So it's 4 plus 4 plus 4. That's how I get the 3 times 4. And then now this is half of a circumference. Circumference is 2 pi r. Half of that is just pi r. So that's how I get the perimeter of the end. So that is pi r right here. Pi times r. Remember the r is 2. All right, where is all coming now? Use the pi in the calculator. Give me 3 significant figures for the p. Where we work out to? 18.3 centimeters. Then to get the total surface area up here, so now just drop in those values. Total surface area. Just drop in these values now. Equal the perimeter times the length first. That is 18.3 times 12 plus 2 times the end area. 2 times 22.2. Let's shift this over a bit. I'll make it a little small. 22.3. 2 times 22.3. What is work out to? Total surface area. How much? 264.2 centimeters squared. Total surface area. But that's not a calculation that we just did. The formula to remember for total surface area, guys. When you have an object with uniform cross section, this one, especially this one, well, all of this. Curved surface area is calculated using the perimeter of the cross section times the length of the object. The length of the object is the distance between the two ends. So whether it's horizontally, whether it's placed horizontally or vertically, the length of the object sometimes is the height. Sometimes in some object, the length becomes the height. Then put it vertically. If it's horizontally, then the length is the length, right? Well, length L in this case is the distance between the two ends of the object. When the object has a uniform cross section like physics. So if you can remember this, that's a quick way to calculate total surface area. Curved surface area is the area on the side of the object, not including the ends. This A means end area, the cross-sectional area, the end area. Remember, the curved surface area is the perimeter of the end multiplied by the length. And you see how we work out this one. It works for any shape that has a uniform cross-section. Good? Uniform solids. All right, good. So that's it. 4 marks to that, you know. That's why it takes so much work. 4 marks. You get me? Very good. Online, everybody understand?
Yeah,
Yes,
I
sir.
think so. Need
Yes,
to go
sir.
over it, but I think so.
Huh? You think so? Tell me why you don't understand. Come, tell me quick where you don't understand. Tell me.
So I said, I think so. So yeah.
Exam is Wednesday, you know. So you better make it stick. Just remember this, man. When you have an object with uniform cross-section, now some persons who work on the total surface area, they'll do a lot of work.
Wait,
Then we
sir.
can work out this piece, plus this piece, plus this piece, plus this piece, plus this side over here, plus the top, plus the curve on the cylinder. Don't have time for that. Don't waste time and work it out no piece by piece, piece. That's waste of time. Right? That's waste of time. Learn the formula for object with uniform cross-section. 2 main formula for object with uniform cross-section. What are the 2 main formulas? 2 main things. Volume equal the cross-sectional area times the length. And the other one is this. Total surface area is curved surface area plus the 2 end areas. And the curved surface area is calculated using the perimeter of the end times the length, and then you add by the 2 end areas. That's total surface area. Those are the main things for object with uniform cross-section, like prisms, triangular prism, any prism of any shape. That's a quick and simple way to do the calculation. Don't complicate it. You don't have to add it up piece by piece. You can remember these things. All right, let's go. What else I want us to find? Calculate the volume. Easy. See here the formula we are using now. The volume of the solid is the end area times the length. We have the end area already here. I have the length already there. So I'm work them out. See that? So it becomes equal to 22.3 times 12. I put it in the CM cube. Work it out for me. What is this? 22.3 times 12.
267.6.
Give me digits. Give me digits.
Sir,
267.6
267.6
centimeter cube.
cubed.
Good. Volume. 3 marks. So that easy something there now. 3 easy marks that. Nice. All right. Next part says the solid is made of gold. Solid is made of gold. 1 centimeter, 1 cubic centimeter. Cubic centimeter means cm cube, right? So they're giving us the ratio now. 1 cm cube of gold has a mass of 19.3 grams. So 1 cm cube equivalent to 19.3 grams. So if you have 1 cm cube of gold, you have 19.3 grams. If you have 2 cm cube of gold, you have 2 times 19.3 grams. If you have 3 cm cube of gold, you have 3 times 19.3 grams. It's simple. It's not complicated. 1 cm cube is 19.3. So 10 cm cube is 10 times 19.3. Get me? Think of it that way. Simple. All right. It says the cost of 1 gram is this amount. The cost of 1 gram is this amount. The cost of 1 gram is this. So it means if you want the cost of 1 cm cube, you have to multiply this now by the 4260. 4262. But anyway, let's work. All right, so this is another relationship. 1 gram is equivalent to money-wise 4262. That's information. So 1 cm cube of gold is this amount of gram, and 1 gram is this amount of money, right? But understand that. Calculate the cost of gold to make the solid. Calculate the cost of gold to make the solid. The solid was made of gold, right? So what we're gonna do, this was the volume of the gold, don't it? Of the solid, right? We're gonna see how much gram this has, don't it? And then also how much gram that has, we're gonna multiply it by this to get the money. Everybody see that? See that, right? Simple as that. So first we need to know how much grams it has. So this amount of volume, so let's can do it by ratio. So 1 cm cube is equivalent to 19.3 grams. Therefore, this amount of cm cube is 19.3 times that, right? 267.6 cm cube, which is the volume in the gold, is equivalent to multiply this times this stuff. Come on again. Let's work it out. 19.3 times 267.6. What is it equal to? 5164.68. Let me shift this over. Let's shift this over. .68, right? Grams, don't it? And then we go again. 1 gram is for this amount of money. So this amount of gram is for this times this amount of money, don't it? Simple, don't it? So this now is equivalent to this amount of money times that, right? 5164.68 times the money for 1 gram is 42.62. Word that out for me and tell me what again. Huh? 22011.8.6 money 66. I put the dollar sign in front of it, right? It's gold, you know, so it's most expensive. It's gold, they're buying the money most expensive. You must have cheap gold here. Told you, and plenty gold. It's plenty gold. 1 gram of gold cost this enough, $42 enough. Right? And you have this amount of gram of gold. They're the most expensive. Make sense? Alright? Alright. One last question before the break. So I was going to break at 7 o'clock. We can finish the next question by 7 o'clock. Yeah, boy, one question. One question. Doing paper 1 now. Come on, let's do this. Exam is around the corner. Let's do this. Exam is Wednesday. Let's do this. Let's do this. Let's do this. All right. All right. It. This question. Ready? This question says, in the diagram, we must use, in this question, use pi as 22/7. All right, so tell us what to use pi for pi. The diagram below shows a scale drawing of a running track. It consists of a rectangle and 2 semicircles. So see the rectangle inside here, so, and the 2 semicircles. So the 2 semicircles basically make a circle, right? So half a circle and a half a circle make a circle. That's all? Yes, sir. All right. What it says? It says the diameter LN and MP, so that those are the diameter 49 across, it's 49 meters across there. So the diameter is 49 and the radius is 49/2, right? So, and it said that this length is 98, down here, so 98 and 98, all right? So we have all the information that give us up here is on the diagram already. So I don't need to read back up here to find anything. Show that the total length of the track is 350 meters. Total length of the track is 350 meters. So we need this semicircle distance plus this distance plus this semicircle distance plus this distance. So we can look at it this way. It's 2 times this length. 2 times this length, don't it? Plus the 2 semicircles, don't it? 2 semicircles is a whole circle. We can show it that way still. Perimeter is the distance around the thing. So the perimeter, the distance around. So this is what asks us for the perimeter. So the perimeter, let's call it P, equals 2 times the 98, don't it? Plus 2 times 2 half a circle. Remember, it's perimeter we want, you know. The perimeter is pi r, don't it? Because the circumference of a circle is 2 pi r. Right? Pi r is the length of this piece right here, and it's 2 of them. So I'm gonna write 2 times pi r. Now what is the r? What is the r in this? The r is 49/2, don't it? So it's pi times 2 times 49 over 2. That's going to give us the perimeter, right? Let's work it out. 2 times 98 plus this 2 cancels this 2, that's all. And the pi is 22 over 7. So it's 22 over 7 times the 49 times the 49. Because the pi is 22 over 7 from this. Times the 49. This 2 cancels this 2. All right, that's all coming now. Just until if I'm up here. This work out to 350. 350. Shown. That was shown. Very good. But okay online?
Yes, sir.
All right, good. Next part. It says, Nathan walks at a constant speed of 1.4 meters per second. That is speed. Speed is going at a constant speed of 1.4 meters per second. And when the speed is constant, then the formula that says speed equal distance over time can be used, right? When speed is constant, then speed equals distance over time. When the speed is not constant, speed not only equal distance over time anymore. All the time, speed equal distance over time is when the speed is constant, okay? Good. So he walks at a constant speed of 1.4. Calculate the time it will take him to walk 7 laps. So if you walk in 7 laps, the distance is traveling, the distance is covering, I should say, traveling, is 7 times 350 meters, don't it? Where that work out to? Huh? How much? 2450 meters. And what is now? Speed. That's right over here. So speed
Sir,
equals
it's 2
distance
zeros,
over
sir.
time. Huh?
Sir,
2 zeros?
yeah.
Thank you very much. So in the class on under what is that 2 zeros? A 1 0.
Oh no, sir, it's
7
1 for
times
real.
350. Huh?
Sir, it's 1, it's 1 0 for real.
1 0 for real. All right. All right. Don't give it away. Don't give it away. All right. So speed equal distance over time, right? And this question is asking over time. So when I transpose this and say time equal distance over speed, you see that? Keep it simple, don't it? So the time that he walks for, that's what I wanted, the time, right? It's the distance that he traveled, 2450 over the time that he took, 1.4. And the answer is going to come out in seconds. Do they want it in anything? They didn't tell us that they want it in minutes. The time is going to come out in seconds because we're working in meters per second. I'm working in meters, so the time is going to come out in seconds. Where is this all coming now?
1750.
1750 seconds. Make sure you see seconds. That's how long it is working for. They want minutes divided by 60, right? They want minutes divided by 60. Good? Oh, it's a lot busy with 2 of them around now. Okay, okay. See here, Tafara. Tafara. So Tafara runs 1 lap in 68 seconds. 1 lap in 68 seconds. Determine the number of laps Tafara can complete in 1 hour, running at the same speed. 1 hour. So since he completed in 68 seconds, I want to convert this 1 hour to seconds. Got it? That's all.
Yes,
And then we're
sir.
going to divide by how long it takes to, what them want, determine the number, right? We're divide the total time by 68 seconds, don't it? That's all. So see here now, the number of laps that is going to cover is the 1 hour, 1 hour over the 68 seconds. Yes, correct? We have converted the 1 hour to seconds now, don't it? So the 1 hour is 60 times 60 seconds, don't it? I multiply by 6 to get in the minutes first, Multiply by 60 again to get it in seconds, don't it? And divide that by 68. What that work out to? How many laps that?
2.9.
How much?
2.9.
52.9 laps. Almost 53. Determine the number of laps completed that he can complete. We're not going to write 52.9, you know. So we're going to write IE completes. He completes 52 laps. Everybody understand that? Question asks how much him complete. So him complete 52 laps. Determine the number of laps the fire can complete. So he completes 52 laps. Not quite make the 53rd one. And go 52.9 laps. Yes?
Sir, why you multiply 60 times 60?
Because I'm converting hours to seconds. Since I'm going to divide by 68 seconds, I want to know what 1 hour is in seconds. So I multiply by 60 first to get it in minutes. I multiply by 60 again to get it in seconds. Understand that?
Okay, sir.
Excuse me, sir.
Yes?
Remember that time we did the exact calculation for the 119 cups, and it went, you got it to 120.
I'm not understanding you. Say that again.
Well, when you did the exact calculations on the 119.9 cups, you went to 120. So I kind of like skeptical about the 52.9 now.
All right. When you did the first thing, he does 1 lap in 68 seconds, right? You want to know, all right, so if we were to multiply this by 68, this is the number of laps. Multiply this amount by 68. We're gonna get the time for 1 hour. Because 1 hour is 60 times 60 seconds. See, look. 1 hour is 60 minutes. Right? 1 hour is 60 minutes. We don't want it in minutes, we want it in seconds. So that's 60 times 60 seconds. So the 1 hour is 60 times 60 seconds. So this is total time in 1 hour. And he's doing 1 lap in 68 seconds. You have to divide by the 68 to get the number of laps. You have to divide by the 68 to get the number of laps. Right? You understand that?
Yes, sir.
Good.
I know we can't round it up, so I know.
You cannot do what? No, you can't round it up. You're going as you have to work it as exact enough. You can't round it up another question. Ask a specific question on the number of laps he can complete. It's when a question asks for a number of something, it's usually a whole number. You know? If you ask
Yeah,
for
yes,
a
sir.
number
I
of
understand.
something.
I was just disconnecting.
Okay. All right. So you have to put 52 laps. He completes 52 laps. This is a specific answer. This right here. This is not the answer. No. 52.9 is the answer. No. This is the answer. The answer in the question. This is the answer. Question asks how many laps he completes. He completes 52. He runs 52.9 laps. The question asks for how many he completed. So he completed 52 laps. But that's not. Answer the question. He runs 52.9 laps, but he completes 52 of them. The 0.9 is not a full lap. See? Good. All right. Next question says, Nathan completes running 1 lap in 72 seconds. Nathan, that's the other person. Initially, he was walking, right? Up here, so he was walking. Now he starts to run. And he completes 1 lap in 72 seconds. That's how long it takes to complete 1 lap. 72 seconds. Tafari and Nathan starts running at the same point from L. Start running at the same time from L. Let's read it again. Tafari and Nathan start running at the same time from point L on the track. So 2 of them start running. Like 2 of them start at the starting point, right? And we start at the same time. Each completed a number of laps on the track. Now remember, one going at 68, and the other one going at 72. So this is Nathan, right? Sorry about that. So this is Nathan going at 72. Let's write it out. And this is Tafara, right? Let's write Tafara. Good. So this person going faster. So this person is going to complete more laps, don't it? Because it's going faster. Taking less time to run a lap, right? So it's going to run more laps, right? So we know Tafari is going to run more laps than Nathan. In fact, Tafari is completing his laps 4 seconds ahead of Nathan, right? So when Nathan reached back L, Tafari gone 4 seconds into his next lap, you know, don't it? Because 4 seconds between them, 4 seconds is the difference in the time. So if we were to visualize it, it's like this is the track. And two of them start here, right? After 1 lap, when Nathan reached right here, so back, after 1 lap, Tafari is somewhere up here, so he's 4 seconds ahead. 4 seconds ahead. You see that? After 1 lap, don't it? But I give it that. After the second lap, is another 4 seconds ahead. After the second lap. After the third lap, is another 4 seconds ahead, don't it? After the 5th lap, is the another. He keeps increasing his distance by 4 seconds. Let's put it that way, right? So basically, to meet back Nathan at the same time, he has to do 72 seconds of 4 laps, of 4 seconds. 72 seconds of 4 seconds. So you basically have to divide 72 by 4 to see the number of laps he must do to match up back with, to meet up back with Nathan. Because every lap is 4 seconds ahead. So to know the number of laps he's gonna run to meet back Nathan, you have to divide 72 by 4. But understand that? That's the number of laps. That's the number of laps Nathan will run. But understand that? So it's almost like a common sense thing. Right? It's 4 laps. So every lap is 4 seconds ahead. And he has to do 72 seconds to match back where Nathan is. So the number of laps he's running is 72 divided by 4. 72 divided by 4 is 18. So basically then, Tafari's lap becomes 72 divided by 4, which is what? 18, don't it? And he would have run 1 lap more than thing there. Because catch him up, you know, don't it? So therefore, Nathan's lap would be 17 laps. So thing they run 18 laps, and Nathan run 17 laps. Huh? Because remember, Tafari run 1 lap more, he's gonna run 1 lap more than him. When you meet him back, he run 1 lap more than him. You understand? You understand that? You know, so simple things harder to explain. Simple things harder to explain. All right, let me demonstrate again. Look at it. So 2 of them running, right? Clearly, this person is going faster. Quiet now. This person is going faster than this person by 4 seconds. So think of the track like that. Let's say both of them started here. After 1 lap, when Nathan reached here, so 72 seconds gone, you know. But Tafari would have been way out here, so 4 seconds ahead. He'll be 4 seconds ahead. Because he would have reached here, so when the time was 68, don't it? 68 plus 4 would have put Tafari somewhere here, 4 seconds ahead. So after 1 lap, he's 4 seconds ahead. After 2 laps, he added another 4 seconds. So it's now 8 seconds ahead, another 4 seconds, don't it? After 2 laps, don't it? After 3 laps, it's another 4 seconds ahead. After 3 laps, don't it? So to find the number, so he's gonna keep doing that, 4 more seconds ahead, 4 more seconds ahead, 4 more seconds ahead, 4 more seconds ahead, until eventually the 2 of them reach the same time. For him to reach that same time, it's gonna basically add up all those 4 seconds to match the 72 seconds that Nathan is doing to meet Nathan again. You understand that now? So therefore, the number of laps that it takes for him to complete one of Nathan's laps, having completed his laps, is like these 4 seconds, you know, is making up a lap to catch up Nathan. You understand me? Good. So he's ahead, you know, but he needs 4 seconds and another lap to get 4 seconds more, another lap to get 4 seconds more. He needs to get 72 seconds more on his lap time to meet back Nathan. So he complete his 68 second lap, but then he needs a 72 second of Nathan's lap to meet him. How many 4 seconds are there in 72 seconds? 18. So if we run 18 laps, because every lap in the 4 seconds more, every lap he goes 4 seconds ahead of Nathan. He needs 18 of those. He needs 18 laps to complete a full lap that Nathan is doing. So when he runs 18 laps, that is when he meet back Nathan. But that would be 1 lap more than what Nathan did. So Nathan did 17 laps. You understand? When he meet him again. So that is it. Simple logic. Or look how we can use mathematics and do it. Let's use mathematics. We'll just use simple reasoning and do it a while ago, right? Let's use mathematics and do it. Watch this now. Let's use mathematics and do it. Let's do it mathematics now. Look now. No. We use mathematics now and do it. Look how we use mathematics and do it. So the answer there so is that Tafari run 18 laps and Nathan run 17 laps. That's the answer, right? What's the mathematics now? 2 of them start at the same time, don't it? Don't it? 2 of them start at the same time. So let's say, let's read it all. So you have Tafari, you have Nathan, right? Tafari running 1 lap in 68 seconds, don't it? And Nathan running 1 lap in 72 seconds, don't it? Now, when they meet again, the 2 of them run the total time, you know. When they meet again, the 2 of them running for the same amount of time, don't it? When they meet again, the 2 of them start at the same time, the 2 of them running for the same amount of time. So let's say T is the number of laps run by Tafari. Then the total time that Tafari run will be 68 times T. Agreed? That time that Tafari run must be equal to the total time that Nathan run, which is 72 times Nathan's number of laps. But understand that. So the question is, what is that value of T and N that will make that side here and that side here equal? What is that whole number value of T and N that will make 68 times T equals 72 times N? Taking T as Tafari's laps and N as Nathan's laps. The 2 of them must complete the thing at the same time, you know. So we can simplify this and search for it. What can we divide this through by to simplify it down? Divide it through by 4. What is the highest common factor of these two? What is it? 4 divided by 4, we get 17T, don't it? Equals, divided by 4, 18N, don't it? So 17 there, 17 our prime number, you know. So 17 times something equal 18 times something. It means this have to be 18. 17 times 18 equal, and this have to be 17 times 17. So that, so one run 18 lap and one run 17 lap. That's the only way them can be equal, because 17 is a prime number. But understand that? See it? Only way them can equal. So same thing again, 18 and 17. All right, so that's a mathematics way to do it, a mathematics way to do it. But the simple reasoning of the 4 laps thing, the 4 seconds thing could also work. All right, and that finishes that question. And now we can break. What time is it now? What time is it we're going to finish? 9 o'clock? So we're taking a 10. Huh? All right. Okay.
So we say we'll go finish 10 o'clock.
Taking a 10-minute break. Taking a 10-minute break. We are coming back to one question. So starting back in 10 minutes. It was original 9 o'clock, but I changed it.
Sir, remember
change
the
it
class
from
done 12
4.
o'clock in a sir, so you can go on.
Huh?
Sir, class done 12 o'clock, sir. Make them stay. You can go on, sir.
Well, I mean, I tell you, somebody someone's done it 12 o'clock. All right, 10 minutes break. 10 minutes break and come back. 10 minutes break. 10 minutes break. 10 minutes break. 10 minutes break. We're going to choose an easy topic for the last one. What should we do? Pattern, we can do the pattern questions, you know. Number 7. Yeah, got them easy, right? Suppose you understand the pattern question and call it a minute. Suppose we finish pattern question. See what else is there. We have statistics. We could do statistics tomorrow. Right? I think we're going to pattern now. If you have time, we can jump on number 1. We're going to do statistics tomorrow. I start the statistics tomorrow. Right? But the statistics, why explain it properly? We don't want to rush it, right? No, so I started early. Come here. It was supposed to be what time? It was supposed to be 9 to 12. Yeah, we started earlier. 9 to 12? That's what we're going to do.
Yes, sir. Make them go late, sir. Come here, sir. We'll continue, yeah.
So you don't like sleep? This is who that. Lori. Lori? Lori's at home. Lori's already at home. But I need to go home.
So lazy.
I need to take on a 10 minutes break and come and 10 minutes break. Sir, I feel like no, I'm on P grade 1 at that one. P grade 1. Oh, so what I'm working for you to get a grade 1. Oh, so what grade 1 is that? I'm thinking I want to sleep all summer. Yeah, when you get the grade 1s. No, but when I come out the exam, I'm never know. Because you're going to come out smiling. No, I'm going to go fix it. No, you're going to come out the exam smiling. Right, boss? When I send me a message and say that was soft, the capital T. Oh, my exam was soft. It's going to be very, very soft. It's going to be nice. Don't worry. It's going to be fun. This exam is going to be fun. Promise you. It's gonna be fun, right, Lori? Right, Lori?
Yes, sir. Yes, sir. Right there.
Yes, of course. It's gonna be fun. All right, let me see what we're gonna do. We're gonna do the number 7s, which is the pattern questions. All right, and that should take us up to 8 o'clock. All right, after the pattern question, let me see what we have left to do after that to finish this thing. We're gonna have statistics. So these are already. These are already statistics. Oh, you know, so we're going to have statistics number 2 and number 1 to do after we finish the pattern. And do that tomorrow. So tomorrow we'll only have statistics number 2 and number 1 we finish. Understand? Yeah, so we're good to go. So we'll finish the pattern questions today. And then tomorrow now, we do statistics, start with statistics. And then we do the number 1 and the number 2 questions. And then we're done. And the revision would have been complete. The revision would have been complete. We would have gone through all the questions. All the questions. You know, so whenever the question, the people, you know, jump down to this, you never see it. Jump to this, you know, we didn't see this part up here. Realize that? Skip over this, you know. We're going to do this question back after the break. We never do it, we skip over it. This question was asking us for reasons, you know. Tell us what the answer is. It tell us that the angle is 45, and they told us to state 3 different reasons. State 3 reasons why this angle is 45. State 3 reasons why that angle is 45. So we're going to do this because we skipped over it. I didn't realize. And then we do the pattern questions afterwards. First pattern question is this one.
Sir, just patterns and that's it, sir.
Now when the pattern, we skipped over one circle theory right here, so a piece of circle theory, a simple piece. Skip over this. We don't know what's coming on the exam, so I prefer to do it. That's about to set a question again that says, state 3 reasons why an angle is an angle. You want to be able to do it and see how we do it, right? So I'm gonna do this one. I think this is the only time I ever see them set a question like this. So I'm gonna do this one, and then we're gonna do the pattern questions. All right, I should be able to finish. Not long after 8 o'clock. But the pattern question is very easy, you know, it can be finished like in, each pattern question can be finished like in 5 minutes. All right, very easy, eh? Yeah, it's a makeup time question. All right, so that's that. So the 1 and 2. One minute to go, 1 minute. 1 minute. Don't worry, sir. Come. Ready. Come in. Oh, sure. All right. Come on, let's go. All right. You have the AC blowing? All right. Let's get hot like this. Come on, ready, guys. Starting again. Online, ready?
Yes, sir.
All right, good. Ready. Come on, turn off that now. All right, so we skip out this question. Just look a piece of a question, part A. Where did the circle theory? We skip over this part of a question. Didn't see it. And the reason I want us to do it, because this was the only time I see them set a question like this. It actually gave you an angle, and they told you to give 3 different reasons why the angle was what it is. Right? And this was January this year. Right? So we can maybe look for something similar again, right? So the question gave us this diagram. W, X, and U are points on the circumference of a circle. TV is a tangent down here. It says this is a diameter. And it said that this triangle is isosceles. And we know that this side and this side is the same length. So it means that this angle and this angle is the same. It's isosceles. And the question says, use appropriate theorem, state 3 reasons to explain why the angle of measure of angle X, angle Z, sorry, is 45 degrees. So we're talking about both sides. Why is this angle 45 degrees? 3 different reasons I want to know. You have one? And between tangent and what? No, but you need some premise angles first. Right? So now the first thing I think is that because this is a diameter, it subtends 90. So that's my premise start. You understand? Angles at diameter subtends 90. And then now, after we have this as 90, we can say this is an isosceles triangle, so these angles are 45 degrees. And from there, so now we can go into some other rules. Like for example, angle between tangent and chord equals angle subtended by the chord up there. Don't it? That would be one. Another one would be that the angle between the tangent and the radius is 90. And if it here says 45, then it's must be 45. And the last one I see is angle on a straight line is 180. Remember, we would have set the premise that here is 45. Angle on a straight line is 180. Over here is 90. Angle on a straight line is 180. You understand? But we need a premise angle. The premise angle that we need is to basically fill out this triangle here. So I'm going to give that as my premise. in order to give these reasons. After I get my premise and fill out this triangle, then I'm going to put my reasons. All right? I'm going to put my premise first. My premise. That's firstly. Firstly. I put it on the paper, I know. Firstly. This angle is 45 degrees. It's 90 degrees right here. Angle WXU is 90 degrees. Why? Subtended by the diameter. Good? And I want to say these two angles equal 45. Don't it? Right? And I'm going to say angle UWX equals angle WUX, which is equal to 90 degrees over 2, which is 45 degrees. Why is that? Because it's an isosceles triangle, don't it? I need that premise first. So I'm basically stating that this angle is 45, and this angle is 45, and this angle is 90. That's my premise. Then we can answer this easier now. First reason, I'm going to use a tangent and chord. That the Z is equal to the 45 up there. Tangent and chord rule. Angle between a tangent and a chord equals the angle subtended by the chord. That's what I'm using for my first one. You don't have to be in the same order, any order, right? So I'm going to state that angle first reason, angle between tangent and chord equals angle subtended by the chord in the alternate segment of a circle. But we don't have to write that part. So I'm basically saying that this angle equals that angle over here. Why is that? Let's look at it again. Just to be clear, angle between this chord and this tangent right here, the angle between the tangent and the chord is 45, is equal to the angle subtended by the chord. The angle subtended by the chord is this. See there? The chord is subtending this angle up here, marked in purple. The chord is subtending this angle up here. So the angle that is subtended by the chord is equal to the angle between the tangent and the chord. That's first reason, right? I'm giving that as my first reason. Second reason I'm going to give them is now tangent and radius, right here. Angle between a tangent and a radius is 90. So if this part of it is 45, then this must be 45, won't it? See that? So I'm going to say, the reason it is 45 because angle between tangent and sometimes I can name the tangent. The tangent is UV. That's a tangent UV. And radius. You can name the radius. The radius is, well, this case, they don't give us. I put in an O on my diagram. Put in an O on my diagram. And say radius UO. And radius UO is 90 degrees. Right? Which is 45 plus 45. So 45 plus 45 means 90. So I'm saying that it must be 90 because remember, I set the premise already, you know, that this is 45, you know, right? So the total angle here is 90, and this has to be 45 by the tangent and radius rule. And then I'm going to use a straight line rule. Total angle on this straight line through this point is 90 degrees. Total angle, a straight line through a point, is 108 degrees. All right, so the angles form at this point on a straight line. This plus this must add up to 180. So this angle over here, so first is 90. So I'm gonna say total angle on straight line. I'm gonna name the straight line TUV is 180 degrees at this point. The total angle is 180 degrees. I'm gonna say that is 90 degrees, that's here, plus 45 degrees, that's here, plus the Z, which is also 45. Yeah, right, the Z. So the Z has to be 45. Understand? So you can present it that way. It doesn't have to be exactly like this, but anyway you want to present your reasons, use your own words. Understand me? But I think these are the three reasons you're looking for. Tangent and chord, tangent and radius, total angle and a straight line. But I think that the first part, to set the premise, is also good. You could maybe set the premise in one of these two. Set the premise in one of those. Premises that we worked out initially that these angles are 45. Then we write the reason why now, since these are 45, why is this one also 45? All right, so that's how I would approach it. All right, let's go to the pattern questions. I run through them quick and fast and call them. Where's the 5 minutes each? 5 minutes each. 5 minutes each. Hey boy, stop it. I'm start half an hour late and I want something. Started half an hour late. Come on, let's go. Question says, the grid below shows the first three figures in a sequence. Each figure is made using a set of small squares of unit length that are both colored, which are shaded, and white. And if we were to just set the diagram, like over here, so shaded, you see them here, so, and down here, so shaded. They have these shaded, and these shaded, and these shaded. So like a form of 7, like the form of 7. All right? So you have 3 across here, and you go up on the diagonal. They have 4 across here, and then you go up on the diagonal. They have 5 across here, and then you go up on the diagonal. So the next one must be what? 6 across, and you go up on the diagonal, don't it? That's all? But I agree with that? So I must draw the next shape. So this was 5 across. 1, 2, 3, 4, 5 across. I'm gonna go 6 across, right? So 1, 2, 3, 4, 5, 6 across, and then go up on the diagonal. How many below the diagonal? 1, 2, 3, 4. So basically, I'm going along the diagonal until I'm exactly back under the first one, don't it? Good. So it's going along the diagonal here, 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 here. That's it. That's my shape. Don't need to do anything more than this in the exam. I'm gonna put this just like it is here. All right. Huh? And shade them shade. That's it. It's not an aesthetic job enough. That's it. All right. That's figure 4. Ready now? The number of colored squares, C, and the total number of squares, T, and the perimeter of the figure, P, follow a pattern. Study the patterns in the table below and answer the questions that follow. Complete rows 1, 2, 3 in the table below. All right, let's look at them one at a time. Looking at these first. I always like to fill out my end first, but the end can help me to fill out the rest. Note that this 11 is not coming in the next line in the pattern. See that? It's not figure 4. They're not showing the values of figure 4. Ready now? These values increasing by 2, plus 2, plus 2. Since the values are increasing by 2, the formula will have 2n as a part of the formula. 2n is a part of the formula. But the first figure has 5. 2 times 1 is 2. We have to add 3 to make 5 in the first figure. So this is the formula for this column. But understand that? Online, everybody understand that?
Yes, sir.
Good. These now, they're going up by 4 plus 4 plus 4. Like these, where they're increasing by the same number. Easier. Since these going up by 4, 4n must be in the formula because it's increasing by 4 constantly. But the first figure has 12. Now 4 times 1 is 4. We're going to have to add 8 to make the 12 in the first figure. What is that? That's the formula for this column. But I agree with that. So I can test it in 2, you know. 4 times 2 is 8. 8 times 8 makes 16. So you can test the formula if you're not sure. Test it with some of the values. This column now, you're basically observing this column and you realize, okay, let's look at it. This is always 2, don't it? But I say that?
Yes,
and
sir.
this is always the figure number, don't it? So it becomes n plus 2 squared. That's what it is. And it will work out to these. You see that? N plus 2 squared. But I can say that?
Yes.
The formula is n plus 2 squared. I don't put equal none. Yes? Yes?
So I don't feel I understand this topic properly.
You don't understand the topic properly?
No. Oh, I
All
got
right.
confused.
So that's why I need to just listen. Because all of them is the same. So I'm going to do it one more time. You want to observe the pattern in how the values change. And I'm saying, usually in my class, we try to work out this line first, the end, the formula. But the formula will help you to fill out the rest of it. Anyway, to fill it out, the formula will help you. So if we can establish a formula for this, and a formula for that, then that formula will help us to fill out all of these values that we don't know. So we use the method where we try to find the formula first. And the formula is easy to find, especially for the type where the values are increasing by the same amount each time. So look at the first column, the values are all increasing by 2, plus 2, plus 2. Always increasing by 2. You realize that? Understand that?
Yes, sir.
So since it is increasing by 2, the formula has 2n as a part of the formula, 2n. This is a part of the formula, but the formula not finished yet. The first figure has 5 in it. In the first figure, n is equal to 1. 2 times 1 is just 2. To get the first figure, I have to add 3 to get the 5 that is in the first figure. So that tells me that the formula is 2n plus 3. Understand that?
Yes, sir. So 2 times 2 is 4 plus 3 is 7. 3 times 2 plus is 6 plus 3 is 9. Okay, yeah.
The formula works. Let's look at this one now. First thing I observe is what the values are increasing by. They are increasing by 4 each time, don't it? Correct?
Yes, sir.
So since they are increasing by 4, I'm saying 4 times n is a part of the formula. But the first figure has 12. In the first figure, n equals 1. So right now, we only have 4 times 1 is 4. We have to add 8 to get the figure in the first line. So this becomes the formula. If you want, you can check it.
Yeah, yeah.
Good. And then this now, the formula is just by observation. you're always adding 2 in the bracket down here. And the first value is always the figure number over here. And then you square it. So the formula is n plus 2 squared. Get that? Understand that?
It's like we just following the formula from the first one.
Follow the pattern. Look at the numbers and follow the pattern. So now that I know these formulae, I can now proceed to fill out these values. So for this one, the n is just 11. I just need to drop the 11 on the end down here. 2 times 11 is 22. 22 plus 3 is 25. So this is 25. See that? Good?
Yes, sir.
Can
Yes,
check if
sir.
this one is correct by dropping the 11 on the 4 right here. 4 times 11 is 44. 44 plus 8 is 52. Is that correct?
Yes, sir. It is.
Yes, sir.
So it works. And since we know the 11 here, we just drop the 11 in the formula here for this one. So it becomes 11 plus 2 squared. 11 plus 2 is 13. 13 squared is 169.
169.
Beautiful. Look at this one now. This is the figure number now. Always that is the figure number now. So this figure number is going to become the n over here. See that? So the figure number is 23 right here. So if I want this 23, use this 23 here, I take the 23 and I drop it on the end. So I get 4 times 23 plus 8. Work it out for me. 4 times 23 plus 8, 100. So this is 100. That's correct? 4 times 23 plus 8 is 100?
Yes, sir. It is.
Good. Yeah, the students here like your accent. Keep talking. Students in Jamaica here, they love the accent. They love it.
Wow.
Let's continue. Want to go to that?
Lorian.
Yes, sir. Why are you
Alright, let's
calling my
continue.
name?
All right, let's continue. Let's continue. Let's finish this. How many white squares are in figure 11? Let's look at it now. Remember, quiet now. Remember that this was the total number of squares. This was the perimeter. These are the colored squares. Question is saying, how many white squares are in figure 11? The total number of squares is the number of white plus colored squares. These are the colored squares. So how can we know the number of white squares in figure 11? Figure 11 is in this line. What we're gonna do? Equals what? The total 169 minus the 25 colored squares. What is that? 144. Want to go to that?
Yes, sir.
Yes, sir.
Beautiful. Finish, 10 marks. Nice and easy. This question is your make-up time question, this pattern question, especially the ones where the values are increasing by the same amount each time. Very easy to do. You can finish this question like in 3 to 5 minutes and make up some time in the exam. All right, next question is on paper 2. Let's look for paper 2. Paper number 2. Let's look at it. Paper number 2. All right, where is it? Right here. Let's go. Paper kind of wobbly, but no problem. It says at an entertainment hall, tables and chairs can be arranged in 2 different ways as shown in the diagram below. So that they can be placed vertically like this. Can be placed vertically like that, vertically side by side like that. Or they can be placed with a joint at the short side. Here they join at the short side, join at the short side. So automatically these will be able to seat more persons, don't it? Why? Why will these be able to seat more persons? Because you're only cutting out the short side. You're only cutting out the short side. Right? While in these, you're cutting out the long side of the tables. Right? The long side is seating 3 persons. The short side is seating 2 persons. So when you arrange them this way, you're going to have less persons seated. Just by common sense. Make sense? Mathematics is common sense a lot of the time. You know? Good. It says, draw the arrangement for table 4 in arrangement L. That's this one. Arrangement L. So the arrangement L is going to put them on the long side, right? So to get the figure 4, we're basically taking this shape and adding one more table beside it, don't it? That's how we're doing, you know. So I'm going to do it easy. I'm going to draw it on this first. I'm going to draw my tables on this first and then copy it out. All right, so I'm going to draw my tables. I'm going to add one more table out here. Like that. I'm going to copy it down. So these are my tables. All right. And I'm going to put on my chairs. So on the short side, I'm putting 2 chairs. On each short side, 2 chairs. And three chairs on the long side. So I need 3 chairs over the end over here as well. And then I need 2 chairs on each short side. Here, 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 there. We'll copy this down. Bam. That is my figure number 4. What can I give it that?
Yes, sir.
Nice and easy. Soft, the capital T. That's a figure number 4. All right, let's continue now. Next page. It says the number of chairs that can be placed around a given table, a given number of table T for either the arrangement L or the arrangement M forms a pattern. The values of C for the first 3 figures, for the first 3 diagrams for both arrangements are shown in the table below. Study the pattern of numbers in each row of the table and then must complete the rows number 1, 2, and 3. So we're going to observe the pattern. So this is the pattern for arrangement L, pattern for arrangement M. So let's look at these first.
So for L, I get 4m plus 6.
Yes. And over here, sir?
I just listen to see if I know it now.
Yeah, man, good. How are you, sir? Tell me what you get for over here, sir.
Right over there, we're going up by 6. So 6n plus 4.
Beautiful. So you have it just like that. So you learn quick. A bright boy. So these going up by 4 plus 4. These going up by 4, 4, 4. These going up by 6. Good. So because these going up by 4, 4n is a part of the formula. And the first value is 10. So 4 times 1 is 4. You have to add 6. That's the formula. These going up by 6, 6, 6. Keep adding 6. So 6n is a part of the formula. But the first figure has 10. 6 times 1 is 6. You have to add 4 to get the formula. That's the pattern. Once you have a pattern, everything dead enough. The rest of it dead. Dead, dead, dead. When n equals 4, well, this one easy because this is the next figure now. So when you put the next figure, you can just continue the pattern. I can just add 4 to this, don't it? Because this is the next figure. So I can just add 4 to this one. Add 4 to this. So what I get? 22. But you can also drop the 4 down here so if you want. 4, 4 is 16 plus 6 is 22. And this one will add 6 to this to get 28. Or you could drop the 4 down here, so, and get 6 plus 24. 24 and 4 give me 28. Any way you want to do it. Then here now, I have 130 there, so. So I have to put this equals 130 to find out the n. See that? Easy as that. I want to find the n, put the 130 equals 6n plus 4. So see it over here, so now, I'm going to write 6n plus 4 equals 130. Subtract the 4 first. I get 6n equals 120. Almost 126, right? And then divide by 6. So the n equals 21. See that? So I'm going to drop the 21 over here. So now, bam, right there. So 21. So this is 21. Now that I know that this is 21, I drop the 21 on this formula. 4 times 21 is 84. 84 and 6 makes 90. So right here says 90. Done. What about that? So
Yes, sir.
with a capital T. All right. That is Lori. That is Lori. Let's continue. Leon needs an arrangement for 70 people. So if you need 70 people, you need 70 chairs, don't it? These are the number of chairs in the arrangement. So you need 70, right? Which arrangement, L or M, will allow him to rent the least number of tables? Which one do you think it's going to be? By common sense, which one is going to be? One where you use the less table. And must the one where you use the wrong side. Right? The one where you, this one, you know. I want to see more people. Because you're using the long side more. You're cutting out the short side, don't it? So it's supposed to be M, don't it? We can't understand M. You have to show calculations. So the answer is supposed to be M. If you look at it, generally speaking, for the same number of tables, you get more seats on the M. You see it? You see that?
Yes, sir.
You can see that? Good. But what them said use calculation to justify your answer. So you can't just say it, right? So use calculation to justify your answer. I could just say M, you know. So you want this question, you want C to be equal to 70. That's what you want to know. You want C to be equal to 70. Right? So you want to put this equals 70 and see what the N is, and put this equals 70 and see what the N is. You understand? So we're doing for the L first. L arrangement L. We're gonna put 4n plus 6 equals 70. Where n equal to down here, so. Subtract that, we get 64. 64 divided by 4 is 16, don't it? 16. Then we're using arrangement M. Arrangement M, we're gonna put 6n plus 4 equals 70. 6n plus 4 equals 70. Subtract the 4, we're gonna get what? 66. And divide by 6, we're gonna get n equal 11. See that? You only need 11 tables when you use arrangement M to see the same number of persons. So the answer is, the question asks us, which arrangement? So the answer is arrangement L. Arrange. Let's write L. Answer is L. Answer is arrangement L. This is my answer, L. Good? Arrangement L. But we know arrangement is L, not L. Arrangement M. It's me right, foolish is an answer. M. So the one the least number of tables. M. M, not L. M. Arrangement M. Use less tables. Very good? Because they're using up the long side more. In that arrangement. Question done. Soft. Paper number 3. Let's do this. Paper number 3. I know you all want to go home. You're too lazy, you know.
No, sir. Yes, sir. I'm just lazy, you know, sir. Send me all right, though.
All right. Paper number 3. Let's finish this quickly then. Let's finish this quickly. This question says, a sequence of figures is made from lines of unit length and dots. The lines form a series of octagons and squares. The dots are placed at the vertices, or at each vertex. The first 3 figures in the sequence are shown. And so figure 3 in the sequence is shown by itself. Add more lines of unit length and dots to figure 3 to correctly represent figure 4. So we basically want to add on to this to make figure 4. So if you look at it, you keep adding to a figure, you basically add this. You add on this to a figure. This is what you keep adding to a figure, right? This thing right here, so. This is what I add to a figure to get the next figure, this. That's what you add to an existing figure. So if I copy this down onto this, like so, then that's my figure 4, and I just need to put in the dots. Dot, 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 dot. And that's it. That's my figure 4. Nice and easy. But I got 2 free marks, that 2 free marks.
Yes, sir.
Next
One more
question.
question, sir. One more question.
Hey, Laura, quiet. Next question says, the number of dots D and the number of unit lines that form the perimeter P forms a pattern, The values for D and P for the first 3 figures are written in the table below. So the pattern of each row and then again complete 1, 2, and 3. Let's look at the pattern. Same thing again. This is going up by 8, don't it? So the formula is just 8n this time. But you don't have to add anything to get 8, right? This is going up by what? 6. This is going up by 6. And the first value is 8. So it's 6n plus 2 is a formula. Then now I want to compete for 4. For figure 4, you can just add back 8 to this, don't it? See that? Or you drop the 8 here, so 32. 32. And then this you can add them out, 6, don't it? Going up by 6. So this is 26, because that's the next figure, figure number 4. Then for here, this is 86. You put this equal 86 to find the n. Let's do it right here. So on a 6n plus 2 equals 86. Subtract 2, get 6n equals 84. 84 divided by 6 is how much? Yeah. What's again? How much? 14. So drop 14 right this as a figure number. You take this 14 and drop it on the 8 here. So 8 times 14 is how much? 8 times 14 is how much?
100.
How much? 112?
Sir, 112.
112. That's it. That finishes that. Next part says for any figure greater than n greater than 1, for any figure n greater than 1. So when n is greater than 1, the 2 values them equal, right? The number of dots at the perimeter equal. Them say the number of dots is greater than the perimeter. Determine the value of n. The value of n for the figure in which the difference between the number of dots and the perimeter is 36. Easy. It's basically when this minus this equals 36. That is all. See that? This is the number of dots as a perimeter. The difference between them must be 36. That's what we're trying to find. So we put this minus this equals 36. That is all. So it's when 8n, like we're saying, is when the number of dots minus the perimeter equals 36. So this is the number of dots, 8n. Minus, I put this in a bracket, 6n plus 2, put it in a bracket because I'm subtracting the whole thing, equals 36. I'm solving this for n now. So if I subtract it out, 8n minus 6n is 2n. So you get 2n minus 2, notice minus 2 equals 36. So the n equals 19, notice, 19. So I'm going to add the 2 first, we get 38. 38 divided by 2 is 19. So n equals 19. That is the answer. N equals 19. Done. Next paper, paper number 4. We're going to finish them one. Soon done. Paper number 4. Let's go. Question number some 5 minutes question. Paper number 4. Then after paper number 4, just paper number 6. I want to do paper number 5. This one right here. This question says, first 3 figures in a sequence of shape formed by connecting lines of unit length are shown below. Draw figure 4. So draw figure 4, you need to put one more than the house business on figure 3, don't you? Yeah, oh, them look like none, some look hot. So, hot. So we're gonna just draw this. Hello? Yeah? I'm not finished yet, you know. Yeah, man, I'm gonna finish just now. Just finishing one more question. Huh? No, I'm just gonna finish this one last question. I'm done. Yeah, one question after this, I'm done. Question like 2 minutes, question, you know. All right. All right. That's Sky advocating for me to end the class on behalf of the rest of it. Anyway, let's go. So I'm gonna add on the next one onto this. Bam. 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 And then like that. And like that. That's my figure number 4. I'm gonna shift it across. Put it there. Figure number 4. Very good. Very good. Let's do this quickly. It says the number of lines L in each shape and a perimeter P, the shape follow a pattern. So the pattern of numbers each row on the table below, answer the questions that follow. Complete the table below showing the number of lines and perimeter in each figure. All right. So let's see the pattern formula. This is going up by 5 each time, don't it? So 5n is a part of the formula plus 1, because that is 6. This is going up by 3 each time. So 3n is a part of the formula plus 2, like 5. That's the formula right there. For this figure, I'll drop the 5 here, so 5, 5, 25 plus 1 makes 26. 26. Drop the 5 here. 3, 5, 15. 15 and 2 is 17, don't it? This is 17. Then this is 66. Put this equals 66. Let's work it out over here. 5n plus 1 equals 66. Subtract the 1 and get 65. 5n equals 65. n equals 13. This is 13. Take the 13 and drop it on here. 3 times 13 is 39. 39 and 2 is 41. This is 41. Done. Anything else? Let's see what else. It says, write a simplified expression in terms of n for the difference d between the number of lines and the perimeter and figure n. The difference between them. So basically, I want the difference between this and this. That's all I want. That's all I want to do. This minus this. So we're doing L minus P. L minus P. The L is 5n plus 1 minus the P is 3n plus 2. This simplifies down to 5n minus 3n, that's 2n. 1 minus 2 is negative 1. Minus 1. Done. Finito. That's it. Difference between the two figures. Last one. Number 6. We don't know what's coming on the exam now. We don't know what's coming on the exam. Don't know what's coming on the exam. Number 6. We don't know. We don't know what's coming on the exam. We don't know what's coming on the exam. Number 6. Ready? Come on, man. 2 minutes. 2 minutes. 2 minutes and it's done. A sequence of figures is made up of stars using dots and sticks of different length. The first 3 figures in sequence are shown. This one I'm not asked to draw nothing. See it? Study the pattern of numbers in each row in the table below. Each row relates to the figure in the sequence. Some rows have not been included. Complete rows for 1, 2, and 3. Same thing again. This is going up by 12. 12n is a part of the formula, and the first value has 12, so the formula here is 12n. These are also going up by 12, don't it? But the first figure has 13, so this is 12n plus 1. What's up? 12n plus 1. Done. Next part. Question says, the sum of the number of, anything to fill out in yourself? Oh, this to fill out. So I must leave it. This equal 156. So this becomes 12n equals 156. N equals what? 156 divided by 12 is much? 13. Drop the 13 down here so I get too much. 12 times 13 plus 1, how much is that? Add 1 to this. Don't all of these are 1 more than this? 157. Yeah, 12n plus 1. 157. Good. Let's continue down here. Question says, the sum of the number of dots in two consecutive figures are recorded. This information of the first three pairs of consecutive figures are shown to you below. So figure 1 and figure 2 is 13 plus 25. Which column am I talking about? Figure number for the dots, right? For the dots, this one. This is the formula right here, right? 12n plus 1. So basically doing the sum of this and this for the first two figures, then this and this for the next two, then this and this for the next two. You see that? That's what they have down here. And they give what the total is, right? They give what the total is. Question says, determine the figure number for figure n and figure 7 and figure 8. Now you see me? I have a formula. You can work out the formula for figure 7. What is the formula for the number of dots again? 12n plus 1, don't it? Number of dots equals 12n plus 1. Some more figure 7 and figure 8, the sum of them, don't it? So it's equal to 12 times 7 plus 1, that's figure 7, plus 12 times 8 plus 1, that's figure 8. Add up this for me, I want to get. Come on, I want to get. Add up this for me, add up this for me. See, you don't want to go, no? I don't want to go. 181, everything come to? 181. Good. Next question says, they want the formula for figure n plus 1. What's the formula again? Dot equals 12n plus 1, right? 182. Don't kill it, don't kill it.
Yes, sir. It was 182 for real.
Thank you very much. Ready now. One for figure n plus 1. Ready? This equal for figure n, it's also going to be this as it is, right? 12n plus 1, that's figure n. Plus, figure n plus 1 now is going to be 12n plus 1 plus 1. If you don't say that. Everybody say that? Okay, you put here, drop this in for when it's figure n, but when it's figure n plus 1, you drop this for the n. See it? That's
Yes,
it,
sir.
and then you're gonna simplify. This becomes 12n plus 1, let's work this out. Plus 12n plus 13. If I cancel that?
Yes, sir.
12 times 1 is 12 plus 1 is
Yes,
13.
sir.
Let's consolidate now. Equal 24n plus 14. 24n plus 14 is the formula. That's the answer. Done. And that is that. All right. So tomorrow, I want to say 5 o'clock again tomorrow. Since it's only 3 things we're doing. We're doing statistics. We're doing statistics, question 1 and question 2. So I originally said 1 o'clock, you know. Right? But if we can leave here 8 o'clock, tomorrow night I'm going to go sleep and don't do no more maths. I'm going to do the exam. That's the plan. 4 o'clock. No, 4 o'clock tomorrow. 4 o'clock. 4 o'clock. 4 o'clock. I'm going to change the schedule. 4 o'clock tomorrow.
Excuse me, sir.
Short session, huh?
I wanted to know, like, if tomorrow you could, like, do more coordinate geometry or something.
Oh, we did the coordinate geometry already. You need to watch the video online. We did the coordinate geometry already. Watch the video. Watch the first video on the YouTube.
Wait, so what's tomorrow? Statistics?
Tomorrow we're doing statistics. And then we're doing number 1 and number 2. That's it. And we're done. We're done. I'm going to finish the revision.
Okay.
Yeah.
Dad,
Yes, guy.
are you what time did you say again? 5 o'clock Jamaica time?
4 p.m. Jamaica time, 5 o'clock Trinidad time.
Okay.
All right, and so it will be a short session.
All right.
All right. Okay, guys, good night.
Good night, sir.
Bye, bye, sir. Have a good night.
Yeah. And you can share the video them with them, the revision video them. All right. Okay, guys, bye. Bye, everybody. Bye, Laurie. Bye, Laurie.
Okay.
All righty. Bye, everybody. Bye. I'm going to end the session now.